Hello everyone, welcome to BYJU'S exam prep. Welcome to your next class in this wonderful series of one shot. I hope everybody is doing very well, guys, and tell me who has joined the session. So as you know, bachcho, that from last few days that marathon session is going on our channel, and this is in this marathon session. Yesterday I have taken one class on network theory. Now today we are going to discuss one of the important subject for the electrical students, that is the power system. So let's everybody join the session and then we'll start. Now after joining a session, you have to do two work. First, you have to share the session among your friends, and second, you have to like the session. So जल्दी से बताओ किस किस ने session join कर लिया. So in the next few hours, we are going to cover important topic of power system. Okay, important topic of power system with the good amount of question, so that you can get overall revision of this particular subject. Now, always remember, when you start revision, hello Rajesh, when you start revision of any subject which is very large, for example electrical machine, for example power system, the syllabus of these two subjects are very large. So when you start revising this subject, always remember you have to revise those topics earlier which repeats, the frequency of which is very large. The frequency of repetition is very large. Okay, so that's why it's very important to understand बच्चों कि आपके पास important topic क्या है, and what do you have a topic which is less important, a topic from where the question will never come. So good morning Sanjeet. Jaswant, is there for EC student? No, Jaswant, for EC the communication will happen today. If I'm not wrong, Saket sir will take communication. Hello Satya, power system is for the electrical. अमित सर बीटेक में कितना परसेंटेज होना चाहिए फॉर एडमिशन इन IITs एमटेक? बेटा 65-70 से अबव होना चाहिए, बट आई विल एडवाइस यू कि अगर 70 से अबव रख लोगे तो ज़्यादा अच्छा है, राइट. Although criteria 65% है, but still the competition is huge, so there may be a criteria where they can select based on percentage also. So it's good if you put the percentage above 70. Yes Satya, I will teach in English and Hindi both, don't worry about that. Actually, I was replying to Amit's question. Okay, so let's everybody join the session and share the session among your friends. I can say that like or live का जो ratio है वो कम है. So let's like the session also. So before starting a session, let me introduce myself. Wait a sec. I guess pen is okay. Before starting a session, let me introduce myself. My name is Shan Mudgal. I have a 7+ year of teaching experience. I'm the gold medalist from IIT Allahabad, 7 times get qualified, and these are my area of expertise. Okay. Now, as you know, that revision marathon session is going on our channel, so you have to attend all the classes so that you can revise the concept effectively with the theory as well as numerical. So we 4 faculties are taking this particular session, and today we are discussing the power system. Okay, so what is going to be the rate of this subject? Let me tell you. Today, first of all, we will start with a fault analysis. Because for the examination you can expect 2 questions from a fault analysis of at least 3 marks. Hello Herok. Okay, after that we will see the stability. After that fault stability, we are going to see insulators. We will going to see the insulators. Then we will see the transmission line parameters. Sorry, transmission line constant. And then we will see the type of transmission line parameters for different kinds of transmission line. Like short, medium and long. Also here is one more topic which is DC distributors, or basically distributors, I will say DC AC both. So this is going to be our today's agenda to cover these topics. Me too Rajesh, me too. Vinay, the notes लेके बैठे क्या class के? Vinay, no, there is no necessary for the notes. You can just watch the videos, because if you have a notes, that's okay. Don't worry here, Rock. I will teach in English, but sometimes the people asking the question Hindi, that's why I'm telling the answer to them. Okay, don't worry. Apart from that, I will speak in English. चंदन सर आपका टेलीग्राम लिंक दीजिए. हाँ चंदन, ट्राई इलेक्ट्रिकल इलेक्ट्रॉनिक्स बाय ईशान मुदगल. ट्राई दिस वन and if you got the channel you can provide link here also. And one more thing sir, we नहीं sir load duration curve होगा. No beta, there will be no load duration curve because it's not the part of a gate syllabus. Today we are discussing about gate examination. In gate examination there is no will be no load duration curve. Economic load dispatch I will take if there will some time. Otherwise economic load dispatch is a very easy topic. There is just a 2 equation. You can do that topic by yourself also, because my focus in today's class is to cover those topics which are very important for the examination and from where you can expect 80 to 85% questions from power system. Apart from that, there will be a topics that will be left, but that you can do it by yourself. And if you have any doubt, I will plan one more session for that also. Okay, let's start. So first of all, let's start with the basic thing. What is the per unit system? Now, per unit system is a very, very important criteria for the power system subject, because almost every calculation you will do on a per unit basis. In a per unit basis, what we deal with, and in a per unit basis, what we deal. See, if you talk about the actual problem of a power system, you will see the calculation part is very large. There will be a rating of a machine which is of thousands of kVA, or there will be a rating of machine which the numerical value is very large. So the per unit system basically used to simplify that calculation. One of the basic use of a per unit system is to simplify the calculation. Now there is a simple formula of a per unit system, which is the actual value in any unit divided by the base or reference value. Now, for any calculation to do in a per unit system, you need to understand one thing, that base or reference value is very important. How you choose the base and reference value, that will take a very good guess in your questions, and from there you can solve the question easily. Now let's talk about the base and reference value. Advantage we will see. So we have if you talk about the base value. So basically we have two type of base value. One is the principal base, and one is the derived base. Now principal base are the voltage base and the power base. And remember, when we talk about the power base here means the complex power S. Now if we talk about the derived base are actually impedance base and the current base. Okay, so this you need to understand. Only these 4 base quantities we have. We don't have a base quantities like real power, reactive power, resistance, reactance. We don't consider those as a base quantities. We only have these 4 base quantities, in which these are the principal base and these are the derived base. Now principal base means that the base will be given in your question, or you can say that this is actually a reference from where you can have to solve each and every question, or also in a practical life. Now if you talk about impedance base, can anybody tell me the formula of impedance base? Can anybody tell me the formula of impedance base? Tell me. It is equal to base voltage whole square divided by power base. It is equal to base voltage whole square divided by power base. Okay, yes or no? Now if you talk about the base current, it is also equal to, if you talk about the base current, it will be equal to wait a sec. If you talk about base current, it will be equal to base power divided by base voltage. But remember, these two are for the single phase system. So in a single phase system, you can find out the base power. You can find out the base current. You can find out a base voltage also. Okay, that is very, very important. Now here you can see, if you have a 3-phase system, if you have a 3-phase system, so let me ask you one question. For a 3-phase system, tell me what will be the principal base voltage. It will be a line voltage or a phase voltage. Think about it. In a 3-phase system, what will be the principal base voltage? Will it be a line voltage or a phase voltage? Tell me. This is very important, because in a power system, you have to deal with a three-phase system, and that's why you have to understand the base values there. Absolutely correct. Absolutely correct. Remember, always remember, in case of a three-phase system, the base power we choose is a three-phase power, and the base voltage we choose is the line voltage. Base voltage we choose is the line voltage. Okay, remember this point. This is very, very important. Now let's talk about different kind of connection for a base value. Different kind of connection for a base value. So we have a star connection. Also we have a delta connection. Okay, star connection and delta connection. Now I have already taken we already have base power and base voltage, and remember, base voltage is actually a line voltage. Now in a star connection, if I talk about base voltage in a phasor quantity, if you can write down in this form, or you can write down in this form. Wait a sec. We can find out phase voltage base. So in a star connection, it is equal to line base voltage divided by √3. It is equal to line base voltage divided by √3. Yes or no? है ना? Simple. In a star connection, phase voltage is equal to line voltage by √3. Now, if you're going to find out the line base current, or you can say the baseline current, एक ही बात है. If you're going to find line base current, that is equal to base power under √3 times of VLB. Yes or no? Under √3 times of VLB. Remember, √3 will come in case of a three-phase system. That's a very important point. Now from here, I can find out phase base quantity, phase base current, that is equal to line base current. Yes or no? It is equal to line base current. Yes or no? Because we are talking about the star connection. Now, why I have find out these quantities? Basically, I have a base voltage, I have a base power. Why I have find out the phase base voltage and phase base current? To find out the base impedance. Always remember, in a three-phase system, when you talk about impedance, that is always a phase impedance. There is no three-phase impedance. There is no three-phase load. There is always a single-phase load which is connected at all the phases. That's a very important point. So when we talk about the base impedance here, always remember, base impedance is equal to phase voltage divided by the phase current. Phase voltage divided by the phase current. This point is very, very important to understand for the base quantities as well as for the general calculation. Okay, so try to solve it and give me the answer. Try to solve it and give me the answer. क्या आंसर होगा यहाँ पे? Try to solve this and give me the answer. Can you write down? Line base voltage whole square divided by the base power. Okay, no need to remember this, you need to understand this, because there will be a lot of things that's coming for you to remember. Okay, so you need to understand this concept, that whenever you talk about the impedance in three phase, that impedance is always a phase impedance. Okay, understand this point. There is always a phase impedance. That's why you can see here, when we find out the base impedance, it is a phase voltage divided by the phase current. Simple logic, right? If you have any doubt, you can ask. Now, next. For a delta connection, I can say phase base voltage is equal to line base voltage Now, if you talk about line base current, that is equal to S base divided by √3 VL base. Simple, no doubt. Now, if you talk about phase base current, that is equal to line base current divided by √3. In case of delta connection, the phase current is equal to line current divided by √3. Phase current is equal to line current divided by √3. Okay? Now find out the base impedance. Base impedance is phase voltage base divided by the line base. Okay? Sorry, my fault, not line, my fault. Phase base. So let's do the division here. So you will find out key. If I write down, correct. You will find out it will be VL base whole square divided by base power multiplied by 3. Yes or no? You can check the calculation. You can check the calculation. Do you get it? Yes or no? Tell me. Do you get it? Yes or no? Is this correct? Check the calculation. Because let me check once. Let me check once. Huh. Okay. There's one mistake. There's one mistake. There's one mistake. Now, if you put the phase here, I line, and if you put the phase voltage, and if you put the 3 will come above. 3 will come above. But also there is one point written by the one of the student that in delta there will be a 3 times of star. In delta there will be a 3 times of star. Right? Con here on. Absolutely correct. So this is the base voltage in case of a delta connection. Okay, so that's why it's important. In case of 3 phase, you have a 2 quantities of base impedance, but in case of a single phase, you only have a 1 quantity, which is this value. Okay, remember this thing. Okay, many times what happen that in your question you only face the star connection. That's why people forget about this. But it is not necessary that you will always get the star connection. That's why you need to understand about a delta connection also. Okay? Any doubt till here? Now let's talk about the advantage of a per unit system. The first advantage is that it is independent of power rating and a terminal voltage. Once you have a base quantity, you can do the calculation easily. And the biggest advantage of a per unit system comes in case of a transformer. Kaise? See very carefully. Wait a sec. In case of transformer, what happened? If you talk about a normal transformer, you have a 2 types of impedance. One is impedance referred to the primary, one is impedance referred to the secondary. Yes or no? You have 2 types of impedance. One is impedance referred to the primary and one is impedance referred to the secondary. Okay, so when you are going to deal with a particular transformer, you have to either refer one side to another side or the other side to the secondary side. Now, but when you deal with a per unit system, so what happened? In a per unit system, if you talk about the primary impedance or if you talk about the secondary impedance, they remain same. And that is the biggest advantage we have in case of a transformer, that the per unit impedance of any reference side will be same. That point is very, very important. This is going to be used in almost every question of your fault, of your stability. Understand this point? Apart from that, per unit impedance referred to either side are same regardless of delta, y or delta y. It means whatever the 3-phase connection you have in case of transformer, the per unit impedance remains the same. Yeah. Computation efforts are also reduced and it is independent of voltage change and phase shift through transformer. For example, in a delta star connection, there is a 30-degree phase shift. Also, in a delta star connection, there will be a change in voltage according to the line voltage by √3, phase voltage by √3. But this will not happen in case of a per unit value. If I'm saying that you have a 1 per unit of voltage in case of transformer, that will remain 1 per unit either at a primary side or a secondary side. That is a very, very important point to note down. Right. So any question series are coming up after this? But I have already taken question series on our power system many times on our channel as well as on app. You can watch that series also. And in this particular session, I'm also discussing the questions. Okay. After each and every topic, I will also discuss the questions so that you can apply these concepts in those questions. Understood? Okay. Now the point comes out, the change of base formula. Now change of base formula you have heard about many times. A change of base formula you have heard about many times. What is the meaning of this? For example, I have a generator. Which has a rating of 100 MVA, 10 kV, and having impedance equal to 0.1 pu. Whenever you have given a rating and a particular impedance in per unit, always remember that per unit impedance is given according to the base of the given rating. Okay, this point is very important. Now I want now this generator is connected to a system. Now this generator is actually connected to a system. Now when this generator is actually connected to a system, what happens? For this system, base power is actually 200 MVA and the base voltage is actually 50 kV. For this system, the base power is for 200 MVA and the base voltage is 50 kV. Now what happens if you use this quantity directly? If you use this quantity directly, this will give you the wrong answer. Why? Because this particular impedance or the per unit value you have is according to the rating given here. But when it is connected to a system, for a system, the entire base values are different. So whenever you are doing calculation on a reactance diagram or the single line diagram, always remember the rating of the entire system must be same. The rating of an entire system must be same, and on that particular rating, your individual per unit value must be calculated. And from there, we find out the concept of change of base formula. So change of base formula is used when the base values are changing and you have to find out the per unit impedance or the reactance there. So Vinay has given the answer. Good. So what is the change of base formula? Z per unit new is equal to Z per unit old multiply by. Tell me, anybody else, is Vinay correct or not? Is Vinay correct or not? Is Vinay correct or not? Base voltage old, base voltage new, whole square multiply by base power new divided by base power old. Tell me, everybody, do you remember this formula? Yes or no? Do you remember this formula? Yes or no? This is a very, very important formula. Almost in every question of fault analysis, you have to use this formula. Okay, in every question of fault analysis, approximately, you have to use this formula. Without this, you cannot start the question. So you will see there is a hardly any chance that 1 mark question will come over this formula. But in every fault analysis question, we have to use this. Okay, so let's try to use this in this formula. Okay, so xg new is equal to xg old, which is 0.1 in this case. Old base voltage, which is 10 kV, new is 50 kV, whole square multiply by new base power is 200, old is 100. तो कितना हो जाएगा ये? 2 divided by 1 by 25. तो 0.2 by 25 आ रहा ना? 0.2 by 25, you can calculate it. 0.2 by 25, 1.25. Ashok, 1.25 कैसे आ रहा है? How you are getting 1.25? Let me solve it. How you are getting 1.25? Kindly check my calculation also. 0.008. We are getting 0.008 now. We are getting 0.008. Also check my calculation. Let me check it. So old was 10, new was 50. The new was 200. It is 100. Huh? Simple. Correct. Correct. Any doubt here? Any doubt here? This formula is very much important to remember, right? Now, apart from the change of base formula, let's talk about impedance also. Wait a sec. Okay, I'm talking about here. Then we will solve this question. Let's suppose I have a transformer. The rating of transformer is 100 by 10 kV, and 50 MVA. 50 MVA transformer having reactance of 0.1 per unit. Yes, we are getting this answer. Now let's suppose I have a transformer. It is separate from the question. Question is different. It is different. Okay. Let's suppose I have a transformer of 100 by 10 kV, 50 MVA of XT 0.1 per unit. I have a question for you. Find out the reactance referred to primary side and reactance referred to secondary side. This is the question. Try to solve it. Find out the reactance referred to, or the impedance I get. Find out the impedance referred to primary side and impedance referred to secondary side. Because I just told you that in a per unit, impedance remains same. This is the impedance at primary side as well as the secondary side. So at per unit, the impedance remains same. But my question is, you have to find out separately, means you have to find out the actual value. Rakesh, 0.008 is for the last question. and my world is trying to give the answer, but okay, koi baat nahi. Apart from that, guys, share the session among your friends. Yesterday there was good number of students. Although yesterday I have taken network, so obviously there was a EC student also. But try to share the session among the study groups you have. Okay, so very basic point I'm asking you. What will be the impedance referred to primary side and secondary side that you need to find out in actual value? Anybody? Anybody? Hey. First of all, to find out that, you have to find out the base impedance. You have to find out the base impedance at primary side and secondary side. Now understand what I'm going to say. Listen very carefully. In a base impedance, you have two values, base voltage and a base voltage and a base power. Base power, if you talk about either side, remains same, because you know transformer is a constant power device. So for a base power, it's going to remain same either you are talking about primary side or a secondary side. But base voltage will change according to the turn ratio. Here you can see this is going to be the base power for a complete transformer, but 100 kVA is the base voltage at primary side and 10 kV is the base voltage at secondary side. Now because of that, what is the base impedance formula? Base impedance formula is equal to wait a sec. It is equal to base voltage whole square divided by the base power. Okay. Now if you talk about primary, so in a primary, base voltage is 100. So 100 whole square divided by 50. It comes out to be 200 ohm. If you talk about secondary, for a secondary, it will be equal to 10 whole square divided by 50 is equal to 2. Okay, 2 ohm. Now what is the actual value? So primary impedance is equal to per unit impedance multiplied by the base impedance. Yes or no? Simple point enough. If you have any doubt, you can ask. So it comes out to be 20 ohm. Now here, what will be the secondary impedance? It is equal to per unit value multiplied by the base value. So per unit value is 0.1 multiplied by 2. It comes out to be 0.2 ohm. So this will be the answer here. You can also use the turn ratio concept that you have learned in transformer. Once you find out the primary side, using the turn ratio concept, you can also solve it. Okay. Refer to primary. By default star lena. Correct me. If nothing is mentioned, so by default you have to take the star connection. Correct. That's why I have used this formula directly. If nothing is mentioned. By chance, if there is mention like it is a star delta, although I should mention that. For example, it is given delta star. Okay, so that you have to use it. But there is my fault. I should mention the connection of transformer. But if it is not given, you have to take the star by default. Understood? Now try to solve the question. First one. हिमांशु सर, मैंने पैरामीटर ऑफ ट्रांसमिशन लाइन कर ली है, लोड एनालिसिस इकोनॉमिक लोड डिस्पैच नहीं किया है अभी. इज द सेशन हेल्पफुल? शुड आई कवर दिस फॉर्म full course? Himanshu, I will advise you that if you haven't done the economic load dispatch, then you can leave it, because the chances of question come from is a 50-50. Either the question will come or that will not come. So you can skip that particular economic load dispatch. In a load analysis, I will tell you, just complete one topic, which is a Jacobian matrix. There is no need to go to the NR method. There is no need to go to the Gauss-Seidel method or any other method. Complete just the Jacobian matrix. How to find out the order of a matrix using of a Jacobian. So just complete that particular topic. Otherwise, there is no need to do anything else in a load flow analysis. Also, one more point: Z bus and Y bus, you can do it. Okay, the reactance of a generator is given 0.25 on a base of this. Find its value on a base of this. Simple enough. Simple. Is there any doubt in this question? There is no need to solve it now. Simple question. We can move further. Next. A single phase 10 kV generator has an internal impedance of 2 watt. Using the rating of a transformer as a base value, that per unit will produce full load current under short circuit conduction. We can skip this question right now because we haven't discussed this thing. Try to solve this one. ABCD. Okay, Manshu, understood? So complete the Jacobian matrix, and if you have time, then complete the economic load dispatch. It will take just the 2 or 3 hours, hardly. And also, guys, after the session, you have to follow the quiz also. The link of a quiz is given in description part also of this video, and also I will share the QR code. You can scan the QR code and go to the quiz part. Other point, we also start the one-to-one mentorship program. So if you have any mentorship program, you can also find the link in the given description. So the per unit impedance of an alternator corresponding to base value of 13 and 25 is 0.18. The per unit value of impedance for a base values are 13.8 kV and 60 MVA. In per unit will be simple. And change of base formula we have to do. Okay. So impedance हो जाएगा. So Z new is equal to Z old. What is the Z old? 0.18. Z old multiplied by old base voltage, which is actually 13.2. New is 13.8 whole square. New is here is 60 MVA and the old given is 25 MVA. है ना? So we can solve this. So it comes out to be 0.18 into square into 60 divided by 25. So 0.395, sorry, 0.395. Okay, option A is the right answer. Option A is the right answer. है ना, Jitendra? And rest of the students, what happened? Simple था. It was simple question. What's for the problem? 0.395. Next one. Now we are going to see the application of per unit system. So see what happened. If I talk about the application, there's only one application. You have to analyze the power system. Now there are multiple ways to analyze the power system. One of the way is using the reactance diagram. Now before starting a reactance diagram, let's talk about what is the single line diagram. Can anybody define what is the single line diagram? Can anybody tell me what is the single line diagram? Anyone? What do you mean by single line diagram? See, listen very carefully. Single line diagram actually represents all the elements which are connected in a particular power system. For example, if you have a generator, then after generator, you have a transformer. After transformer, let's suppose you have a load. Again, you have a transformer. Again, there's something. So single line diagram is just the representation of all the elements connected in a particular power system. Not distribution system, we will say. The correct word is a power system, connected in a power system. Now, what is the reactance diagram? Reactance diagram? So this is actually a single line diagram. My fault. This is actually a single line diagram. We have. Here you can see what information you can gather. We can gather the information that generator is connected of a star connection in which neutral is grounded. We have a transformer of star delta in which star is grounded. We have a transformer here also, delta star, and we have a motor connection also, 2 motors. Generally, we don't show the load in a reactance diagram, static load. Generally, we don't show the static load on a reactance diagram. That's why the static load is not shown on this single line diagram. Otherwise, if you talk about the complete single line diagram, you also have to show the load. For example, there is some load connected. But because I'm going to talk about the reactance diagram, so there will be no static load. Remember this point. Now tell me why. Give me one particular reason why we don't consider a static load in a reactance diagram. Can anybody give the answer? Why we don't consider the static load in a reactance diagram? Anyone? Think about it. See, listen very carefully. When we talk about a reactance diagram, we actually going to use the reactance diagram in case of a fault analysis. Now, when we talk about a fault analysis, you have to consider those elements which actually delivers the power. Okay, or you can say the fault current. But in case of a static load, whenever the fault occurs, the static load does not deliver any power to a fault point or any current to a fault point. And that's why we don't consider the static load in a reactance diagram, because it's not going to help in your fault analysis. So Jitendra was correct. Well done, bacha. Per unit will constant. But I show this concern. Why the per unit is constant? Per unit is constant for everywhere. Have you seen anywhere where per unit is changing? No. Per unit is constant everywhere, right? Now let's talk about the reactance diagram. Now in a reactance diagram, as the name suggests, we have to convert each and every element with their reactance. But remember one point very carefully. When the complete power system you have, they must operate on a single base system. Now let me tell you one point here. First of all, for the complete system, the base power is always same. For a complete power system, the base power will be same for every element you have. But if there is no common base power is given, you can take the base power of a generator. If there is a multiple generators given, then the generator with the highest rating will be considered as a reference generator, and you can take the base power of that generator. Otherwise, in almost every question, the complete base power will be given. Understood? Static load means shunt capacitor, sir. No. Static load means the resistor, also the shunt, also the capacitor, also the inductor. The load which does not change its value, that is the meaning of static load. Okay. Now, next point is very important. The base voltage. Now, base voltage of a system will change whenever the transformer come in picture. So let's suppose the base voltage here is VB1. Now, on a secondary side of transformer, there will be a different base voltage. Now, again, the transformer occurs. So here also, you will have a different base voltage. But remember, this base voltage is actually linked by the turn ratio of a transformer. So understand this point very carefully. Whenever you have to draw the reactance diagram, first you have to make sure that all the reactances of the elements are on the common base. Now, meaning of common base is, for the whole system, the base power is same, but the base voltage will change according to the transformers connected and according its ratio. Any doubt in this statement? Tell me, guys, yes or no? Any doubt in this statement? Because this point is very important and it will help you to solve the question based on fault analysis. Any doubt on this particular statement? What is the base voltage? How you can choose it? Okay, fine. Good. Now, what is the reactance diagram? It's the electrical network equivalent to a complex power system network by replacing all power system equipments with its reactance. Now, again question, why only reactance? Why not the resistance? Because we also have an impedance diagram. But why we don't use the impedance diagram? Think about it. Now, let's talk about generator. For generator, the reactance diagram is simple. You have to replace it by reactance in series with a voltage source. Generally, we take it as a 1∠0 per unit. This is a general case. If something is different, that will be given in the question. So, generally, we take the generator voltage as 1∠0. This will be a generator reactance also in a per unit, JXT, in a per unit form. Okay? Tell me, guys, why we don't consider the resistance? Why we don't consider the resistance in the reactance diagram? Or simply, why we don't use the impedance diagram? We consider the lossless system to minimize loss. No, Vinay? No. Now, if we talk about the motor also have a same feature as a generator. For example, the motor is connected here. This is generator. Now, if you convert this into a reactance diagram, then again you have a 1∠0, and here it will be XMG. Okay? Anybody else? Worst case analysis, correct? Arun, absolutely correct, beta. See, again, reactance diagram used in a fault analysis. We are doing the fault analysis. It means we want to check what will happen when the actual fault occurred in your system. So for that, we need the worst case analysis. If the resistance is present, then majority of fault will damp out. majority of fault will damp out, and then when you create a system, there will be a chance that the fault current will be more than the expected. So we always goes to a worst case scenario when there is no resistance, there will be no damping of a fault, and hence we can create a system according to that. Because after that, whatever with the fault current occur, that will be less than our calculation, and our power system will be safe. Because in the end, we do the fault analysis to actually consider the protection of a system. Fault analysis is done to actually connect the protection of a system. So the selection of circuit breaker, the selection of relay based on your fault current. So in case of a fault current to be maximized, your resistance should not be present in a circuit. So this is the point why we don't consider resistance in the reactance diagram or in the fault analysis. But sometime in numerical you can find out. In numerical you can get it. Okay, so then don't worry about that. Now, if you talk about the transformer, in a reactance diagram, if you talk about the transformer, any connection of transformer, they will be replaced by a reactance. Any transformer, okay? It can be star, delta. Nothing worry about that. It will be considered by simple reactance. Now, after transformer, we have a transmission line. Transmission line is also replaced by a simple reactance. Okay. Transmission line is also replaced by a simple reactance. Okay. Understood? Okay. Now let's solve one question based on this. Let me write down the question. And everybody should try it. I know questions of power system are lengthy, but beta, if you don't try it during your practice sessions or during your revision, then how will you expect it by yourself that you are going to solve the question in exam? That's why try each and every question first. So I'm giving a system here. You have to draw the reactance diagram of this system. Okay, this is line. This is transformer of star connection, star grounded. This is 100 by 10 kV, 100 MVA of 0.2 per unit. If you talk about G1 has a 100 MVA. 50 kV, 100 MVA, 50 kV. And here I can say 100 MVA, 50 kV, and it is reactance given. Reactance given is equal to 0.1 pu. Generator 2 is 100 MVA, 100 kV. Generator given is equal to 0.1 pu. For motor also 100 MVA, 20 kV. XM given is 0.3 pu. Okay, everything is given. So we have given this and this. For the line is actually J20 ohm per phase. Achha, one more point. I forget to tell you. One more point, that reactance diagram is a per phase diagram. Okay, this point is going to help you to solve question further. So right now, just remember it is a per phase diagram, and how it will help you, I will tell you after some time. So what you have to do, you have to draw the reactance diagram. Here you have to draw reactance diagram. Okay, try this question. Very basic question for your examination. Sir, draw reactance diagram on my fault on base 100 MVA, 100 kV on G1 side. On a base of 100 MVA and 100 kV on G1 side. Matlab this side. Okay. Satya, sir, what is the worst case analysis means? Dekho beta, what happens? See, understand this point carefully. You are a power system engineer. You have to design the power system. you don't know about you right now. You don't know what's going to happen in the future, whether it will be a lightning, whether it will be some kind of short circuit. Nothing you know right now, because you are actually designing the system right now. So when you are designing the system right now, first you have to select the circuit breaker you have to use. Now, which type of circuit breaker you will use, that will depend on what is the strength of the fault that will occur on a system. But when you're designing, you don't know the strength of a fault. It can be of different kind of strength. So what you're going to choose, you are going to consider the worst case in which the fault current will be maximum, and then you can choose the circuit breaker according to that. So that if in a worst case scenario, when the fault current is maximum, the circuit breaker can protect your circuit, then for the fault current less than that, your circuit breaker will also work. So that's why we always do the worst case analysis. Now when you talk about resistance in a system, resistance do two things in a system. First is it causes the damping. Second, it will reduce the current. Okay, second, it will reduce the current. For the high resistance, the current will reduce. There are 2 points. Now, if you consider a resistance during the fault analysis, then you are going to get the fault current which is less than the maximum. And then you choose the circuit breaker which is less than the actual maximum circuit breaker rating. And when the particular fault occur, it may happen, your whole designing will get damaged. That's why we do the worst case analysis, so that your particular system will remain unaffected for any kind of fault, or remain protected, non unaffected, remain protected for any kind of fault. Okay, that's why we don't consider the resistance there. Any other doubt? Okay, let's do this question. Now, first of all, you have to find out the impedances or reactances on a complete common base. So what you have to do, first of all, for a complete system, the base power remains same. It is 100 MVA. The base power remains same for the complete system. The base power is the base power is going to be 100 MVA. The base power is going to be 100 MVA for the complete system. Now let's talk about the base voltage. Now see the base voltage. Whenever the transformer comes, always remember the base voltage will be different on a primary and a secondary side. According to a question, there is a 100 kV base voltage at G1 side. G1 is this one. So here the base voltage, let VB1, is 100 kV. So because the generator is connected, according to a turn ratio, if you provide the 100 kV voltage, you will get the 10 kV voltage. So at this side, the base voltage is 10 kV. So understood how to choose the base values here. This is the first step to draw the reactance diagram, that you have to check, you have to choose the base values correctly. Okay, now let's talk about generator 1. If you see the generator 1, the reactance is given on its own rating. It means this 0.1 pu is according to 100 MVA and 50 kV. So first we have to convert it according to the base we have given here. So, I don't have a page here. Okay, this you have already done now. This is a simple concept, you know. So I will do the calculations here. Because I cannot add page in between the session. So let's do the calculation here. So let's talk about generator. So xg1 new is equal to xg1 old multiply by old base voltage. Old base voltage is 50 kV, new is 100 whole square. And if you talk about the base power is same. So how much you are getting? 1 by 2, 1 by 4, 1 by 4, so 1 by 40, so 0.025 pu. You will get 0.025. Absolutely correct. Everybody try to solve it and give the answer in the comment section. There are 24-25 people online. Try to give the answer in the comment section. Also like the session, bachcho. Wait a sec. I guess there's a system problem. Let me check on my phone. Meanwhile, find out each and every value. Okay, हाँ ठीक है. Fine. Find out remaining values. So let's talk about xg2. xg2 new is equal to old is 0.1, base voltage, it is same. There is no change. So you can see there is no change. There is no change. There is no change because G2 is already given on the base that we are going to find out. There is no change. Okay. Now let's talk about transformer. Let's talk about transformer. Now transformer, we have, where is the transformer? Okay. We have a 0.2 and this is 100. This is 100 whole square. Now think about it. Now think about it. Sorry, my fault. Tell me one point here. This is going to be important for you. This is going to be important for you, bacho. This is going to be important for you. Tell me the new base voltage for the transformer. Tell me the new base voltage for the transformer. This is going to be important. Tell me the new base voltage for a transformer. This is a transformer. This is rating. What is the new base voltage for a transformer? Think about it. Okay, let me explain you. When you're going to apply the change of base formula, in case of transformer, always remember one point very carefully. You have to choose either the primary side or the secondary side, or I can say higher voltage side or a lower voltage side. You have to choose the side. For example, if I am choosing the primary side, for a primary side, the old base voltage is 100 and new is also 100. So there is no change. If I'm choosing the secondary side, then the old base voltage is 10 kV and new is also 10 kV. So there is no change. So if you see in this transformer, there is no change in a particular base value. So the reactance remains same and that will be a 0.2 per unit. So I can say 0.2 multiplied by, I'm choosing the primary side. So old base voltage 100, new is also 100 whole square. Power is also same, 100 by 100. So there is no change. 0.2 pu. This point is very, very important. Let me again explain you. Whenever you are using a change of base formula, you have to choose the side of a transformer, because on either side the per unit value remains same. So if you are choosing a primary side, here you can see the base voltage is 100 and the new is also 100. If you are choosing a secondary side, the base voltage is a 10 and new is also 10. So there is no change. Now let's talk about motor. So motor guess में क्या है? 0.3 है ना? 0.3 into rating is new is how much? 10. No, sorry. We have a old here ना? 20 divided by 10 whole square. 20 divided by 10 whole square multiplied by 100 by 100. So it comes out to be 1.2 pu. Yes or no? Motor case 1. Why you are getting a different answer, Ashok? Why you are getting a different answer, bacha? Tell me. What's the problem? You are getting very different answer. Now let's talk about the line. If you see the line carefully, line is given in actual value. So first you need to find out the base impedance here. Now when you're going to find out the base impedance, always remember, line is always connected in star connection. Always remember that. So base voltage for the line क्या होगा? Base voltage whole square. Which base voltage? For the line, this is the base voltage. Base voltage whole square divided by the power base, right? So base voltage 10 square divided by 100. So it comes out to be 1. It comes out to be 1 pu. 1 ohm. It comes out to be 1 ohm. So what is the line per unit is equal to actual value, which is J20 divided by the by the per unit by the base value. So it comes out to be J20 pu. Okay, understood? Gautam, VB1, VB2 classes of CSC division starting. No, there is no class. That I don't know. That I don't know. Vinay, VB1 and VB2 repeat, please. Okay, I will repeat that. Gautam, I will tell you. Okay, listen very carefully. VB1 and VB2. Whenever the transformer comes in a picture, in a single line diagram, whenever there will be a transformer, there will be a different base value on its primary and on its secondary side. There will be a different base value. Now that base value will be chosen, will be connected according to a turn ratio. So here you can see on a primary side, I have a base voltage of 100 kV. Why? Because this is given in a question. So to a secondary side, the base voltage will be according to a turn ratio. So here you can see that turn ratio is 100/10. So we have 100/10. So if you provide a 100 kV here, so VB2 will be a 10 kV. VB2 will be a 10 kV. First point, need to understand this. Second, when you are going to use the change of base formula for a transformer, you have to choose one side. You have to choose one side. Either choose the primary side or choose the secondary side, because on both sides the per unit value remains the same. So if I am choosing a primary side, so at this side the new base voltage and the old base voltage is same. On the secondary side, new base voltage, old base voltage is same. That's why there is no change in a particular reactance of a transformer. Base power is also same as a system. Okay. XM calculation please. XM wrong हो गया? Check करना. Kindly check is the XM is wrong or correct. Is XM is wrong or correct? It is 0.3 multiplied by old base. Old base कितना है? 20 kV. New base कितना है? 10. Old base by new base whole square multiplied by 100/100. Why I'm getting? I am 1.2 now. Arin, where I have done mistake? Tell me, Gautam, where I have done mistake? Because here you can see na, old base multiplied by, sorry, my fault. Old reactance multiplied by what? Base में क्या होता है? Old reactance multiplied by old base voltage divided by the new base voltage, है ना? तो 100 ये है ना बच्चों? See Arin, see very carefully. This is 100 MVA and the rating of a motor is also 100 MVA ना. So that's why 100/100 हुआ ना. है ना Arin? See very carefully. This is base power. This is base power. This is base voltage, which is new by old. है ना? Simple. बेटा voltage is 10 kV है बच्चे. See very carefully ना. वही तो मैं समझा रहा हूँ बच्चा. See very carefully. Because of transformer at motor side, the base voltage is 10 kV, not 100 kV. Because 100 kV base voltage is at primary. So they have been we are 10 kV because the transformer come in picture. That's the same point I'm explaining you. And the same point I have explained here also. One more point. The same point I have explained here also. Whenever the transformer come in picture, there will be a different base voltage at both sides and linked by their turn ratio. Okay? Correct. Now let's draw the reactance diagram. We have everything here. Now for the simplification, what I am going to do, I am going to change one thing. The value is very large. I am going to change one thing. Let's suppose it is J2 ohm for the simplification. So it's going to be J2 per unit. It will J2 per unit. Okay, but just itna hi. Okay, now draw the reactance diagram. So see very carefully. We have two generators. Connected like this. We have two generators. Then I have a transformer. Then I have a line. And then I have a motor. Then I have a motor. Okay. So for two generators, what we have? 0.025, 0.1. 0.025, 0.1. 0.025, J 0.1. Here we have J 0.2. Here we have J 1.2. And for the line, we have J2. And everything is in per unit. Everything will be in per unit. Understand? Now, this is the bus bar 1. Let's suppose this is bus bar 2. I'm just giving a random name. Bus bar 3. Okay. So this is the reactance diagram. Question is complete. Any doubt till here? This is the reactance diagram. Question is complete. Any doubt till here, bachcho? Tell me. Okay. No doubt na. Let me ask you one more question. After this, the question is, I'm going to write down the question here only. This you already know na, generator, how to replace the generator na. This you don't require na in notes. This is a very basic thing. You already know. Now the question is find XTH with respect to bus 2. Find XTH with respect to bus 2. The question is Find extinction Thevenin reactance. Thevenin reactance. Find Thevenin reactance with respect to bus 2. Find Thevenin reactance with respect to bus 2. Try karo. Once. Try it. Try it. Okay, try karo. Find Thevenin reactance with respect to bus number 2. With respect to bus 2. Now, on respect to this bus, you need to find out the Thevenin reactance. So, when you find out the Thevenin reactance, what's the criteria? The voltage source will be short circuit. Voltage source will be short circuit. Here you will see these two are parallel and series with 0.2. So, J0.025 is parallel to J0.1 and they are in series with J0.2. Okay. Now, this side, J2 and J1.2 are in series. J2 and J1.2 are in series and both of them are parallel to each other according to the, because we have to find out XTH from here. So here you can see both of these sides are parallel to each other. So this will be the relation will be formed. Yes or no? Tell me. Any doubt in this relation? Any doubt in this relation? This will be the answer now. We can solve it easily, but this is a relation we got. Now let's solve it. Let me find out the answer. 0.025. तो अराउंड 0.22 के आसपास ही आएगा. ठीक है. Shahul or Ashok is right. Shahul and Ashok is right. Good. Okay. Vinay, what happened, beta? What happened? Just use the calculation. Simple. From this network, you can see very carefully. From this network, you can see very carefully what will be the Thevenin reactance. So this is the XTH. This is the XTH. Now, can you also represent this network into a Thevenin circuit? You can also represent this network into a Thevenin circuit. So this will be the Thevenin circuit here. This is the XTH. This is the VTH. VTH always remain 1 angle 0. If nothing extraordinary mentioned, you can take VTH 1 angle 0 here. Now this is according to the bus 2. Bus number 2. This is according to a bus number 2. This is according to a bus number 2. Okay. Now just for the revision purpose, because I know you already know about a fault analysis. So just understand this point carefully, because you already know about a fault. We are doing the revision here, right? So just understand one point here. If I say the fault occur here, if I say that the fault occur here, the fault occur here, the fault occur here, है ना? If the fault occur here and I need to find out a fault current, I will tell you which kind of fault. Just right now, assume that the balanced fault occur. So let's suppose the symmetrical or balanced fault occur here. So if a fault occur here, then what happens? We convert this network in this form. We convert this network in this form. And then I can say the fault occur here. So if the fault occur here and I need to find out the fault current, I need to find out a fault current. So I can easily say fault current is equal to VTH divided by XTH. Yes or no? Yes or no? I can easily say the fault current is equal to VTH divided by XTH. Tell me, any doubt here? कि if the fault occur, for example, question की starting में यही होता. For example, in the starting of question, they will ask you what will be the fault current at bus B. What? Where is the bus? This is bus. Bus 1, bus 2. Let's suppose in the question it is given you have to find out the fault current that occur at bus 2. So what is the procedure? First find out a reactance diagram. After finding out a reactance diagram, find out the Thevenin circuit. In case of Thevenin circuit, just you need to find out the Thevenin reactance. The voltage is always remain 1. Okay. And then you can find out a fault current like this and your answer will be complete. But this will be a per unit value. And your answer will be complete. So this is actually the symmetrical fault analysis. This is actually a symmetrical fault analysis. This is actually a symmetrical fault analysis. Understood? है ना? Simple है. Symmetrical fault analysis is very simple. Right? Next point. Now let's talk about balance system. Let's see. Sir, why VTH is 1 per unit? Why VTH is 1 per unit? Because simply the reason is we take the base voltage and the system base, both are same. So if the actual value and your base value is same, then the per unit will give you 1. The per unit will give you 1. है ना? Simple. Although Jitendra, there is also some explanation there. I'm not going to that explanation. For the examination purpose, you can just take VTH equal to 1 per unit everywhere, unless until it is not mentioned. Okay. Then three-phase fault. No, I'm talking about symmetric balance system. We will come to a fault also. The last one was a three-phase fault. Yes, the last one was a three-phase fault I was talking about, but I will explain that after few slides. Now tell me, what is a balance system? What do you mean by balance system? Balance system means two things. Each phase is displaced by 120 degree, and next maximum magnitude of each phase voltage and current are equal. This is known as the 2 points to identify whether the system is balanced or not. Now, if you talk about a balance system, you have two parts. In a balance system, we have both balanced load and a balanced source. We have both balanced source and we have a balanced load. Now, what is the meaning of balanced source? Balanced source means the source will generate the voltage. The source will generate the voltage of this characteristic. That is the meaning of balanced source. What is the meaning of balanced load? Balanced load means each phase has equal impedance. Balanced load means each phase has equal impedance. That is the meaning of balanced load. So if you have a balanced load, if you have a balanced source also, then the current which is going to flow in a network is also a balanced. Okay, so this is the meaning of balanced system. Now in a balanced system, we talk about the phase sequence, or we talk about phase sequence in every system, but there is one concept of phase sequence. Now there are two types of phase sequence you have heard about. One is ABC and one is R by B. We are going to deal with ABC, although both are same. Now what is the meaning of ABC phase sequence in case of balanced system? Can anybody tell me? I'm telling you the system is balanced and the phase sequence is ABC. What is the meaning of this? It means for a ABC phase sequence, it means B phase lags phase A by 120 degree. C phase lag phase B by 120 degree, or C phase lags phase A by 240 degree, or you can say C phase leads phase A by 120 degree. Any doubt in all of these four statements? Tell me. Anyone? Any doubt in all of these four statements? This is the meaning of phase sequence ABC. Now the meaning will change if you change the phases. So any doubt in these four statements? Everybody? 4-point doubt, sir? 4-point. Okay. Now I said, see very carefully, Gautam, that C phase lags the phase A by 240 degree. Now, whenever we talk about the leading and lagging, we actually take the angle less than 180. But here the angle is greater than 180. So to get the angle less than 180, you have to subtract the 240 from 360. And whenever you subtract the angle from a 360, the leading lagging will reverse. So 240 degree, when you subtracted the 360, you got 120, and that's why lagging become leading. That's why lagging become leading. Or you can say, or you can also see one point here also. This is a phase, or you can say one point here also. Let's suppose this is X, this is Y. These are two phasors. These are two phasors. Now in our last class yesterday, I told you phasors rotate in an anti-clockwise direction. So this is the rotation of phasor. This is the rotation of phasor. This is angle phi. So you can say from here that Y leads X by phi, because Y is ahead of X. But if you observe the same phasor diagram, from this side, you can also say X leads the Y. So X leads Y by 360 minus phi, which is the reflex angle. You can also say like this. That's why we have a fourth point. Okay, so these 4 points are very important. I hope you understand these 4 points. Now let's talk about the phasor diagram here. So our phase sequence is ABC. It means I'm talking about voltage. So VA. So when we talk about ABC, what happened? You take phase A as a reference. So it is 0 degree. Phase B lags the phase A by 120. And phase C leads the phase A by 120. Right? So this is the phase A. Leading means anti-clockwise direction. So this is the phase C. Lagging means clockwise direction. So this is the phase B. Understood? Yes or no? So this is the phasor diagram. Okay, understood this. This is the phasor diagram. Okay, any doubt here? Now let me tell you one more point. Right now, this is the phase sequence of ABC. If I say that I have CAB, so is the CAB is same as ABC? Tell me, is CAB phase sequence is same as ABC phase sequence? Tell me this point. Is CAB phase sequence is same as ABC phase sequence? The answer is yes. The answer is yes. Always remember, you can have 3 name of a single phase sequence. You can just have to rotate it. If the C come here, so AB. Now here you can also say BCA. So all of these 3 phase sequence represent the same phase sequence. Okay. For example, let's talk about CAB. What you will say? A lags C by 120. Now say the same thing we have write down here. You know? That's why. Again, I can say or you can say B lags A by 120. The same thing we have write down there. So always remember, this is very, very important point, that ABC, CAB, BCA, all of these represent the same phase sequence, and this is by definition known as positive phase sequence. Ananta Bacha, the GATE exam is just a 1 month left, and you are asking whether this is in your EC or not. You should be aware of your syllabus, bache. You should all aware of your syllabus, right? We are talking about a power system. You haven't touched the book of power system in your college if you are from EC branch, right? So this is not in your branch. Even the 3-phase system is not for the EC branch. Okay. So this is the positive phase sequence. Now, if I want to change the phase sequence, then what we have to do? We just have to change the sequence of 2 phases. For example, ACB. Now, when I said ACB, well, we have a ABC, we have changed it to ACB. Then this have a different phase sequence. IN में बोल रहा था. No, this is not in IN. If you are giving the GATE exam in electrical also, then it's okay, but in IN it's not. Now ACB is a different phase sequence. Let's draw the ACB. VA, VC, and we have VB. So this is the different phase sequence. This is a different phase sequence. Okay. Now just like ACB, we have BAC, we have CBA. So these two represent the same phase sequence. This is known as negative phase sequence. This is known as negative phase sequence. Okay, so we have a two type of phase sequence, positive and negative phase sequence, and positive represented by these three phase sequence, negative represented by these three phase sequence. Any doubt here? Any doubt here? Tell me, guys. Simple enough? Simple. If you have any doubt, you can ask. Right? We can go further. Okay. Now let's talk about the unbalanced system. Now, unbalanced system. Why does a system become unbalanced? Can anybody give me the idea? Why does system become unbalanced? So there are two reasons, major reasons. Because of that, a system is unbalanced. Either load is unbalanced, either the load is unbalanced. Unbalanced load means the phase impedance, the per phase impedance are different. In phase A, we have a different impedance. In phase B, we have a different impedance. So either the load is unbalanced or unsymmetrical fault occur. So there are two ways through which the system can be unbalanced. Either your load is unbalanced or there is a fault occur. Okay, so load is unbalanced is not in our course. It's not in our course. We are only deal with the fault analysis. So because of the fault, the system become unbalanced. Now unbalanced system means that a particular phase sequence are not displaced by 120 degree, and second, the magnitude of voltage or current is not same. That is the meaning of unbalanced system, and that is very, very important. But the problem is the study of unbalanced system is a very, very difficult task, because you will get approximately 12-13 equations, and solving 12-13 equations is very difficult task. So what happened? There is a scientist who has given one theorem known as the Fortis theorem. There is a scientist who has given one theorem known as the Fortis theorem. Have you heard the name? Have you heard this name? Fortis theorem. He has given the theorem Fortis theorem. What is a Fortis theorem? That unbalanced system can be breakdown. Means unbalanced system of n phases can be breakdown into n-1 balanced phase, n-1 balanced phase plus 1 co-balanced phase, Yeah, balanced system, I will say. I will say like balanced system and co-balanced system. So this is the Fortis theorem. This is a Fortis theorem given. According to a Fortis theorem, your n-phase balanced system can be break down into n-1 balanced system and one co-balanced system. Vinay, I know many tumhara sir. n-1 balanced system and one co-balanced system. Now we have a three-phase system. Right? So for a three-phase system, for a three-phase unbalanced system, we have two balanced system. Which are the two balanced system? Positive phase sequence that we have seen just few minutes back, and the negative phase sequence. Both are the balanced system, negative phase sequence, plus one co-balanced system. Or co-balanced system is also the unbalanced system, but a co-balanced system. Okay, so in this way the three-phase system is going to be divided. Okay, so let's talk about it. For example, I have an unbalanced system having a phase sequence ABC. This is the phase sequence given. Okay, so let's draw unbalanced system. This is the unbalanced system, you can see. Now according to Fortis theorem, this can be divided into three systems. One is the positive phase sequence. Now when you talk about the positive phase sequence, we use the symbol 1. So this is the positive phase sequence because its phase sequence is similar to the system. Its phase sequence is similar to the system. That's why it is a positive phase sequence. Okay, it is a positive phase sequence. Plus negative phase sequence. Now in a negative phase sequence, the phase sequence will reverse. In a negative phase sequence, the phase sequence will reverse. The phase sequence will reverse. Okay, so here the phase sequence is ACB and it is the negative phase sequence. It is a negative phase sequence, and here I will say co-phasor system. Here we have a co-phasor system. A naught, B naught, C naught. Okay, it is a co-phasor system. Co-phasor system means all the phases have a same phase sequence. There is a zero phase difference between them. There is a zero phase sequence between them. Sir, yesterday's marathon PDF of network theory, that I forgot to upload. No? I will upload it. You can join my Telegram channel. I will upload there. Right? So we have a co-phasor system. So this particular unbalanced system can be divided into these three systems. These three systems, and it is very, very important. It is known as the zero sequence. It is known as the zero sequence. It is known as a positive sequence and it's known as a negative sequence. For a zero sequence, we use the 0. For a negative, we use 2. For positive, we use 1. Okay? Any doubt here? Now, how you will write down this thing? For example, I'm talking about voltage. So I can write down voltage of phase A, and voltage of phase B and voltage of phase C. Understand? This side, I'm talking about the unbalanced system. This side, I'm talking about the unbalanced system. So phase A is divided into 3 parts. So it will be VA1, VA2 plus VA0. Similarly, VB, it is VB1, VB2 plus VB0. Similarly, VC, it is VC1, it is VC2 plus VC0. You know? So in this way, you can divide it. But the problem arises here. Another problem arises here. For example, I know VA, I have a value of VA, VB, VC. I have a value. I require the value of these systems. So if you see here very carefully, there will be how many variables here? 1, 2, 3, 4, 5, 6, 7, 8, 9. There actually are 9 variables here. So to find out 9 variable, you need a 9 equations. So there must be some way so that you can reduce the number of equations. Because we are using a Vortex theorem to reduce the calculation, not increase the complexity. And absolutely correct, Rajesh. For that, we have to use the alpha operator. For that, we use the alpha operator. What is the alpha operator? Alpha operator is actually 1 angle 120. It actually rotates phasor. In anti-clockwise direction. It actually rotates phasor in anti-clockwise direction. For example, let's suppose I have a positive phase sequence. I want to find out VC1 in terms of VA1. So what we can do? J is different. J does not rotate because it is multiplied by 1 angle 120. Na? So VC1, VA1. What you will do? See very carefully. What you will do? Here, there will be an anti-clockwise rotation. If I rotate VA1 by anti-clockwise, I can reach to VC1, right? So what I have to do? I have to multiply by alpha. Okay. Now let's talk about VB1. So here, what you can do? By multiplying by alpha, you reach C1. By multiplying by alpha, you can reach V1. So I can say alpha square VA1. Yes or no? I can say alpha square VA1. Any doubt here? Now similarly, if you talk about the negative phase sequence, A2, C2, B2. Now in a negative phase sequence, what happens? VB2 is alpha times of VA2 and VC2 is alpha square times of VA2. Any doubt here? कोई भी doubt हो पूछना. If you have any doubt, you can ask. Okay. So we got VB2 and VC2. Now if you talk about the zero phase sequence, in a zero phase sequence, it is simple. VA0 is equal to VB0 is equal to VC0. VC naught, because that was a co-phasor system. That was a co-phasor system. So from there, the calculation will be reduced a lot. How? See carefully. I can write down phase A is equal to VA naught plus VA1 plus VA2. Everything is a phasor quantity, okay? VB is equal to VA naught, because VB naught is equal to VA naught, plus VB1. VB1 is alpha square VA1 plus alpha VA2. Sorry. Now VC. It is VC naught plus alpha times of VA1 plus alpha square times of VA2. Now what you need to remember? You need to remember this matrix. VA, VB, VC is equal to 1, 1, 1, 1, 1, alpha square, alpha, alpha, alpha square. You need to remember this matrix, bachcho. Okay? You need to remember this matrix. Now, where you can use this matrix, understand. You can use this matrix when you have a positive phase voltage, negative phase voltage, or a zero phase voltage, or I can say when you have a balanced voltages here and you need to find out the unbalanced. When you have a balanced voltages here and you need to find out the unbalanced, then you can use this particular equation or this particular matrix. Okay, so I can also write down VABC is equal to, the matrix is A, augmented matrix, and this is the V012. But remember one point very carefully. The next statement I'm saying, remember this statement very carefully. While calculating this matrix, we have taken phase A as a reference. You can check here. We have taken phase A as a reference. Let's suppose in question they can also change the reference phase. They change the reference phase to phase B. Then your whole matrix will be changed. Your all the calculations will be changed here. Okay. So when you're remembering this particular matrix, you also need to understand the procedure. I told you just if the reference phase will change, the whole thing will be changed. That's why the procedure has been written here. So VABC is A, V012. Now, if the unbalanced voltages are given and I need to find out balanced voltage, so I can also write down this equation. Now what will be the A inverse? Very simple. 1 by 3. 1, 1, 1, 1, 1. Interchange here. Alpha, alpha square, alpha. This is the A inverse. Understood? Yes or no? Understood this point? Yes or no? Tell me. Understood this point? A inverse. This you need to remember. One more thing. Alpha operator. Alpha square is 1 angle 240 degree. Alpha cube is 1. So 1 plus alpha square is equal to 0. Just for the mathematical calculation, nothing else. Okay, jaldi se batao. Understood now? Only Vinay has given the answer. There are 30 plus students online. Tell me. Understood that point? Okay, let's talk about power. We have VA IA conjugate plus VB IB conjugate plus VC IC conjugate. This will be a three-phase power. In case of a unbalanced system. This will be a three-phase power. You have to add the power of each and every phase. Good evening, Ashok. Good evening. Okay. Good morning, chal raha bhai. You have to add the power of each and every phase. Phase A, phase B, and phase C. Right. Now, also it is equal to 3 times of VA0 IA0 plus VB0 IB0 plus VC0 IC0. Just remember this. No need to go to a derivation here. No need to go into a derivation. Or you can also write down as per unit. ये काम नहीं करेगा. also you can also write down as per unit is equal to VA naught IA naught. Everything is in per unit. Everything will be in a per unit. Everything will be in a per unit. Okay, understood? Understood? Right. Now let's talk about a neutral current. Achha, one more thing. Oh, let's talk about this also. The same thing you can write down for current also. The same thing you can write down for a current also. 1 alpha square alpha square I A naught okay, I A naught I A1 I A2. Okay, same thing you can write down for a current also. Same thing you can write down for a current. Beta, that was per unit. In a per unit, what you will do? In a per unit, what you have to do? You have to divide by 3. Now, when you calculate the per unit power, the 3 and 3 will cancel out. The 3 and 3 will cancel out. Remember, per unit. Okay, now let's talk about neutral current. What is a neutral current? Sir, only zero sequence in power. Only zero sequence in power means, beta? Only zero sequence in power means? Can you elaborate? Now let's talk about a neutral current. Let's suppose I have a system like this. Let's suppose I have a system like this. Okay, and here I have a neutral. So this is IA, this is IB, this is IC, and this is IN. What is going to be a neutral current? Neutral current is equal to IA plus IB plus IC. Yes or no? Neutral current is equal to IA plus IB plus IC. Now tell me, what will be the neutral current based on IA naught, IA1 and IA2? Tell me. What will be the neutral current based on IA naught, IA1 and IA2? See very carefully. So I can write down one thing. See very carefully. What is IA plus IB plus IC? It is equal to IA naught. You can use the reverse formula. Kaise? Let me explain you. Don't worry. Let me explain you. You can use this formula. IA naught, IA1, IA2. This formula is also true. 1 by 3, 1, 1, 1, 1, 1, alpha square alpha is equal to IA, IB, IC. From here, what is IA naught? Tell me, from here, what is IA naught? IA naught is equal to IA plus IB plus IC by 3. Yes or no? From here, I can say IA naught. So this becomes 3 times of IA naught. Do you understand this point? Yes or no? Do you understand this point? 3 times of IA naught. See very carefully. If you're going to calculate IA naught here, it will be equal to IA plus IB plus IC divided by 3. Divide by 3. So what is the IA plus IB plus IC? This is 3 times of IA naught. 3 times of IA naught. It means neutral current. It means neutral current only flows in zero sequence. Neutral current only flows in a zero sequence. Neutral current does not flow in a positive or a negative sequence current. So in a positive and negative sequence, the neutral current will not be occur. That's why whenever you have a neutral impedance connected, that only comes in a zero sequence diagram. Neutral impedance never come in your positive or in your negative sequence diagram, because in positive and negative sequence there is no neutral current. The neutral current can only lies in case of a zero sequence. Understand this point? Yes or no? Understand this point? Now, next point. Let's suppose I put an impedance here. Let's suppose I will put an impedance here. Neutral impedance. Let's suppose I put a neutral impedance here. If I put a neutral impedance here, so what will be the neutral voltage? That will be neutral current multiplied by neutral impedance. Now, neutral voltage is equal to 3 times of IA naught multiplied by Zn. Neutral voltage is equal to IA naught multiplied by 3 times of Zn. So I can also write down in this form. I can also write down in this form. Now that's why, and that's why, bacha, that's why here, when you talk about a zero sequence network, you multiply the neutral reactance by 3. You multiply the neutral reactance by 3 because that 3 comes from here. That 3 comes from here. So always remember 2 points. One, the neutral current only flows in a zero sequence. Second, when you draw the sequence networks, when you draw the zero sequence diagram, in that case, you will show the neutral impedance, and that neutral impedance will be multiplied by 3. That neutral impedance will be multiplied by 3. These 2 points you need to remember and understand. Arin beta, which last line? You are talking about this one or you are talking about this one? This is number 1, this is number 2. So which line you are talking about? Which line you are talking about? Number 1 or number 2? Number 1 or number 2? Tell me. There are 2 last lines here. Yeah. So always remember these 2 points. Now, if you talk about if there is no, for example, I have a system of star connection. Just assuming I have a system of star connection without any neutral. Without any neutral, I have a system of star connection. Okay. So in that case, there is no grounding. There is no grounding. There will be no zero sequence current. There will be no zero sequence current. Okay. Number 1. You see very carefully, bacha. From this formula, IA, IB plus IC by 3. Can you find out this thing? Can you find out this thing using this formula? IA naught is equal to IA plus IB plus IC by 3. Kaise? Simple. Matrix multiplication. Simple. Matrix multiplication. Right? Now, when you have a IA plus IB plus IC, it is equal to 3 times of IA naught. So, I put 3 times of IA naught here. I put 3 times of IA naught 1 here. Now here, I'm talking about a neutral voltage. So what is a neutral voltage? Neutral voltage is across the neutral impedance. So it is equal to neutral current multiplied by the neutral impedance. So IN multiplied by ZN. IN is equal to 3 times of IA naught. Simple. है ना? And this line if you're talking about, तो बेटा यहाँ से IA, IB and IC are flowing. तो IN is equal to IA plus IB plus IC ना? Because we are talking about the KCL. Whatever the system, balance and balance, KCL will always applicable. KCL will always applicable. Now try to solve this one. Try to solve this question. Arin bacha, you can see this thing. Neutral current is IN. Neutral current is IN. It is equal to 3 times of IA naught. Can you see the positive sequence current or a negative sequence current here? Nahin na. There is no IA1 or IB1 here na. There is IA2 here. There is no positive or negative sequence current. There is only a zero sequence current in this equation. So from this equation, you can say na ki neutral current only flows in a zero sequence. Yes or no? Is there IA1 or IA2 here? No. That's why. Now next question. Try karo. Solve karo. Mathematically you can prove na. Mathematically you can prove that neutral current is equal to 3 times of IA naught. So we have a 3-phase system, IA, IB, IC. We need to find out IA naught, IB naught, IA naught, IA1 and IA2. Understood? I mean, yes or no? Or if you have any other concept, you can also write down. This should be like this. You can also write down. Also, bachcho, share the sessions among your friends so that more and more students can join. I know electrical में बच्चे कम रहते हैं, but still. So I can see. Okay, good. हाँ, okay. तो connection सही चल रहा है. There is a connection here. Okay, fine. हाँ. Option B. Now see very carefully. This is the problem when you don't have a strong base. See this current carefully. This is the balanced current. The magnitude are same and each phase is displaced by 120 degree. The magnitude are same and each phase is displaced by 120 degree. What happened in this kind of situation? In this kind of situation, or I can say in balanced current, only positive sequence present. The negative and zero sequence current are not present. Because negative and zero sequence come in picture because of unbalanced system. Because of unbalanced system, you have a negative and zero sequence. But when you already have a positive phase sequence, when you already have a balanced system, there is no need of negative and zero sequence. So option A is the right answer. Option A is the right, sorry, not A, sorry, my fault. Option 0 IA. Both are same, I guess. No. Option D is the right answer. Option D is the right answer. Then option D is the right answer. What is the right answer here? IA1 is equal to IA. IA2 is equal to 0. IA not equal to 0. This will be the answer. This will be the answer. Option D. None of these. None of these. Okay? So whenever you have a balanced system, there is no need of negative and zero sequence. वो होता ही नहीं है. There is no negative and zero sequence. That is actually the concept of unbalanced system. Right? Next. Find the sequence component phase current A. Find all the sequence component of phase current A for the following system. For the following system means you need to find out IA0, IA1 and IA2. You need to find out IA0, IA1, IA2. IA0, IA1, IA2. So solve this one. Find all the phase sequence component of current A of the following. And remember, at least 3 marks question will come from the fault analysis. 3 marks question will come from a fault analysis. Okay, that's why this chapter is very important. That's why this chapter is very important. See very carefully. There is no neutral path. When there is no neutral path, neutral current is 0 or also IA0 is 0. It means the zero sequence current will be 0 because zero sequence current only flows when there is a neutral present. Since there is no neutral present, it will be 0. But you can also find out using the formula. Kaise? See very carefully. We have IA given 100 angle 0. We have IB given 50 angle minus 100. What is IC? IC plus IA plus IB must be equal to 0 because all the current entering here and none of the current is leaving. No current is leaving. No current will be leaving. So IC will be minus IA minus IB. Okay, one thing you can write down here. Now, what is the formula to find out all the sequence current? IA0, IA1, IA2. It is equal to 1 by 3, 1, 1, 1, 1, 1, alpha, alpha square, alpha, IA, IB, IC, IA, IB, IC. Now, if you talk about IA0, it is equal to 1 by 3, IA plus IB plus IC. Now, you can see IA plus IB plus IC is 0. IA plus IB plus IC is 0. So IA0 is nothing but equal to 0. Equal to 0. So that's why the zero sequence current is 0 because there is no neutral present here. Rappa. No, better not the whole syllabus, but we are covering the important topics. We are covering the fault, stability. Then we will cover the distributor. Then we will cover the insulator. And then we will cover the inductance, capacitance. And if the time permits, we will see the ABCD parameters also of different kind of lines. Okay. Previous question sequence was ACB. The phase is A. हाँ बेटा, sequence is ACB. Correct. The frequency. अच्छा. Oh, correct. The phase sequence here is ACB. है ना? Phase sequence यहाँ पर ACB हो गया. ACB. It is a negative phase sequence given ना? Okay. My fault. You were right, Jitendra. Very well done, bacha. Very well done, bacha. See, bacha, very carefully. This kind of mistakes happen. See very carefully. You will see the system is balanced. See very carefully. You can see the system is balanced, but the phase sequence is ACB. Why? Because this is the reference phase. C lags the phase A. B leads the phase A. So the phase sequence is ACB. It means it is a negative phase sequence given. It is a negative phase sequence given. and system is also balanced. System is also balanced. System is also balanced. So only IA2 is present, which is equal to IA. IA1 is 0 and IA0 is 0. Well done, Jitin beta. You have see very clearly. So option C is the right answer. If the phase sequence ABC is present, that will be the positive phase sequence. Also, if it was a balanced system, then in that case IA1 is equal to IA and IA2 is 0, IA0 is 0. Okay, so phase sequence you also need to check. The phase sequence you also need to check. So they also seen the phase sequence there. Okay, my fault, I haven't seen this. Okay, now what is the IA1? What is IA1? IA1 is 1 by 3 IA plus alpha IB plus alpha square IC. Can you calculate this? Can you calculate this? There you have to use the calculator. So can you calculate this? You can calculate by yourself. Okay, we are not spending time on the calculation. That you can do it by yourself. है ना बच्चा? Just try to understand the concept. Calculation you can do it by yourself. So understand this point. Any problem here? The main point here is that since there is no neutral present here, no neutral path present here, the zero sequence current will be 0. Zero sequence current will be 0. Okay. Now let's talk about the sequence diagram. But usse pehle, we have seen the reactance diagram, right? We already seen the reactance diagram. So reactance diagram is only created for the balanced system. It is only created for the balanced system. And it is also known as the positive sequence network. Okay. So for a balanced system, we have a reactance diagram. It is also known as the positive sequence network. When exam में इतनी calculation नहीं होगी. Although this was, if I'm not wrong, this is the examination question also only, but that question has been asked when the manual calculator was allowed. In examination, since you have a virtual calculator, so the calculation will be according to that. So if you see the previous year question after 2016, you will find out the calculation part is much easier as compared to before 2016, because at that time manual calculator was allowed. Okay, so reactance diagram is only drawn for the balanced system, also known as the positive phase sequence. Now, when you have an unbalanced system, you cannot draw the reactance diagram. Means you cannot draw the per phase diagram at that particular point if you have an unbalanced system. Because in case of unbalanced, there is everything different in each and every phase. Phase A will be different, phase B will be different, phase C will be different. So that's why we have to draw the sequence network. In a sequence network means we have three types of sequence: positive sequence, negative sequence, and zero sequence. So we have to draw three diagrams: positive phase sequence diagram, negative phase sequence diagram, and zero phase sequence diagram. Now positive and negative will or I will say positive phase sequence diagram is a balanced diagram, so it will exactly like a reactance diagram we have drawn earlier. We have drawn the reactance diagram now. It will be exactly like that. For example, we have a generator here. Alternator generator. So what will be the reactance diagram for a generator? So this is the positive sequence impedance. This is the positive sequence diagram or network. This is the positive sequence network of generator, which is exactly like of your reactance diagram. Where Z1 is the positive sequence impedance. And this will always given in a question. The value of positive, negative, and zero sequence impedance always given in a question, so you not need to worry about that. It will always given in a question. Okay? Otherwise, if you talk about this is actually the subtransient reactance, but we are not going into that particular depth. Subtransient reactance, we are not going into that particular depth because that is not necessary for the revision class. So for your exam, they will always give you the positive, negative, and zero sequence impedance. Now here you can see we have a generator EA, Z1, VA1, and this is the positive sequence current. So what is going to be the VA1? VA1 is equal to EA minus IA1 Z1. So the same thing we have note down here. Any doubt in this case? Beta Repa, if you have done the power system earlier, and then you are watching this video, then yes, you are getting a good, or you can say the maximum marks. But if you haven't done the power system earlier, then no. Okay, then no. Now, negative phase sequence. Negative phase sequence network will be exactly like a positive phase sequence network aside from the voltage source. When you create a positive sequence network like a reactance diagram, just remove the voltage sources from there. Once you remove the voltage sources from there, you will get the negative sequence diagram. You will get the negative sequence diagram. Okay? So in a negative sequence diagram of an alternator, there will be no EMF. There will be no EMF. There's only the negative sequence impedance. Now current is flowing in this direction, so it will be plus and minus. That's why we have negative sequence voltage is minus IA to Z2. Okay? Next. Zero phase sequence. Now in a zero phase sequence, I told you that neutral will play a part there. The neutral path will play a part. If you see the previous cases, the neutral is connected, but we didn't connect the neutral in positive phase sequence and in negative phase sequence, because neutral current does not flow in a positive or a negative phase sequence. We only draw the neutral in case of a zero sequence network. So in a zero sequence network, you have to show this neutral. You have to show this neutral, and when you show the neutral impedance or reactance, it must be multiplied by 3. It must be multiplied by 3. I have explained this earlier. Okay? But sir, explain once again. Which part, beta? Which part? So you have to put the 3 times of Zn there. Now let me tell you one more point. For example, I have a generator like this. I have a generator of star connection. I need to draw the zero sequence network. Now here you can see there is no neutral connected. So I will draw it like this. Sorry. This is a zero sequence impedance. It is a zero sequence impedance. Since no neutral is connected, you have to show the open circuit. Next case. If the solid grounding is given. So in case of solid grounding, you have to show by short circuit like this. This is the solid grounding case. This will be the solid grounding case. Understood this point? Yes or no? Now if you talk about next one, or you can say reactance grounding is given. Then in this case, 2 reactance will be connected. This will be Z0. This will be 3 times of Zn. And or Xn you can say. Understood? Yes or no? But a CS is what? Control system you are talking about or something else? But control system you are talking about or something else? To understand this phenomena, understand this thing, it's very important. Let me explain you again. Once again here. For example, I have generator like this, in which it is star ungrounded. It means it is star ungrounded. But computer science is not planned right now. That I'm not pretty much sure. Okay. So it is a star ungrounded. So if you want to draw the positive sequence diagram, no need to see the neutral. This is the positive sequence diagram. Negative sequence diagram, again, no need to see the neutral. But when you draw the zero sequence diagram, you have to check the neutral. Since there is no neutral path, you have to show the open circuit. So this is the positive sequence, negative and zero sequence diagram of this type of generator. Understood? Any doubt here? So for every type of generator, the positive and negative sequence diagram remains same, but the zero sequence will change according to neutral. Okay? Yes or no? The same for the motor. Let me write down. Same for motor. Okay? Next. Now the important point is transformer. For the transformer, there will be the separate questions comes in your examination. Draw the zero sequence of this transformer and that transformer. So if you talk about the transformer, see very carefully. For a transformer, whatever transformer is given, whether it is the star delta, star delta, star, anything, whatever the type of transformer is given, this will be the positive sequence and this will be the negative sequence for a transformer xt1 xt2. The value will be given in question. The value will be given in question. It will be the xt1, it will be the xt2. So whatever the transformer is given, no need to worry about the type of transformer or the grounding of a transformer. Whatever the transformer is given, simple, there will be the xt1 and xt2. Okay, but for a zero sequence network, you have to follow this shortcut. You can see you have 4 switches, S1, S2, which are series, SP1, SP2, which are parallel. Now understand this switching carefully. In case of star grounding, the switches will be closed. The series switches will be closed. For example, if primary side is a star with ground, then S1 will close. Or if the secondary side there is a star with a grounding, then S2 will close. Okay. If there is a star without any grounding, then this switches will be open. So that's why it is written, when you have a star with grounding, then the series switches will be closed. Now delta, if you have a delta connection, then the parallel switch will close. If you have a delta connection, then parallel switch will close. For example, we have a star delta connection. Since star is grounding, so series switch of primary side will be closed. And here you can check delta. For delta, parallel switch will be closed. The parallel switch will be closed. So this is the zero sequence diagram of this transformer. Now for the transformer, see very carefully. This will be the ZT0 and this will be 3 times of Xn. Because the neutral is present. Now one more. If I have a star grounding at both primary and secondary side. So since I have a grounding, the series switch will be closed. It will be ZT0. Now let's suppose I have delta. So at primary, I have a delta. So series switch will be open. Parallel switch will be closed. Series switch will be open. The parallel switch will be closed. Like this. Similarly, let's suppose I have a delta star. So at primary, I have a delta. So primary series switch will be closed. Shunt switch will be series switch will be open. Shunt switch will be closed. Now at secondary side, I have a star with a grounding. So this switch will be closed like this. Any doubt here? You have to follow this shortcut. Okay? You have to follow this shortcut, that you have a star with grounding, then the series switch will close. If you have a delta, then parallel switch will close. Any doubt here? This is the most important for a zero sequence network. Direct question come in your examination. For example, this question. In this question, you have to find out the correct zero sequence network of star grounding and delta. Tell me, which is the answer here? Which option is the answer here? Tell me. A, B, C, D. Give the answer in comment section. A, B, C, D. Option C, option A. Option A is the right answer. Why? The primary side is star, so the series switch is closed. Secondary side is delta, so parallel switch is closed. Then you have a Zn, so Zt plus 3 times of Zn. Right? Now if you talk about the option C, you can also find out the connection from here. Option C is like this. Right? If you talk about option B, option B is for this. If you talk about option D, there is no connection for option D. Why? Because they have given a neutral impedance and actually they have closed both the switches. So both switches cannot be closed at either side. the parallel or series. Only one switch can be closed or both can be open. Next. Now try to solve this question. It's a very good question. It's a very good question. Try to solve it. Try to solve it. Correct. Correct Ashok. Correct Pyash. Correct Vaishnavi. A generator is connected to a transformer which generator can. अच्छा वो होगा ठीक है. A generator is connected to a transformer which feeds another transformer through a short feeder as seen here. The zero sequence impedance values are expressed in per unit on a common base and are indicated in figure. The Thevenin's equivalent zero sequence impedance at point B. At point B. Okay. Try करो. अच्छा question है. A very good and question for your examination. Very good question for your examination because for a zero sequence direct question come. For a zero sequence direct question come. So try to solve this one. Point B. This is point B. This is point B. Try to solve this one. And again, bachcho, share the session among your friends because I can see the views has been stick, live count has been stick to 2025. And try to watch the whole video in a go. Okay, don't think like this that you will see this video after some time and after that what happened, that time will never come because there's other subjects also you need to focus. So when on this channel we are providing the marathon session on a daily basis, so just follow those sessions and after that you can do your own studies. No? So let's see because exam is very much near, bacho. Exam is very much near. Let's draw the zero sequence network first. I have a generator of resistance grounding. Generator of a resistance grounding. So for a generator, I have a zero sequence impedance. Then I have a resistance grounding. This is for the generator, right? It is 0.03. It is 0.03 J. For the resistance, I have to multiply it by 3. I have to multiply it by 3 because it is in neutral 0.25. It comes out to be 0.75 pu, right? After that, I have a transformer. This is delta connection. This is star with grounding. So when you have a delta connection, the switch will be open series 1. There will be a particular parallel switch, and then I have a zero sequence reactance, and this side I have a star with grounding. So the series switch is closed. This is 0.1. This is 0.1. Then I have a transmission line. Then I have a transmission line of J 0.05. Let me check. I have a transmission line of J 0.05. Again, I have a transformer such that it is a star grounding. It's a star grounding. So a star grounding, and there we have a delta. There we have a delta like this. So it comes out to be how much? 0.07. J 0.07. After that, I have a motor. It's actually a motor. There is a motor here. After that, I have a motor. And the reactance of motor is not given. Reactance of motor is not given now. Actually, it's missing here. Let me write down. Motor is J 0.25. Motor is J 0.25. So reactance of motor is not given. Okay, fine. So there is a motor given for a motor, and there is a resistance. There is a resistance here, right? So it is J 0.25. And again, it is 3 times of 0.25. 0.25. It comes out to be 0.75. pu. And this is the point B. Any doubt in this? Any doubt in this? Tell me. This is the zero sequence network of this one. We will solve the question, but before that, tell me, any doubt here? Any doubt here? How to draw this diagram? This is for the transformer 1. This is for the line. This is for the transformer 2, motor, and this is for generator. Tell me, bachcho, any doubt here? Vinay has given the answer. Okay, fine. But everybody, any doubt in drawing zero sequence? Push low because this is going to be an important one. Now they're asking, what is the Thevenin's equivalent at point B? If you see from point B, only this side is, or you can see only this impedance. There is no impedance or resistance connected here. So if you talk about the Thevenin impedance for the point B, that is going to be J 0.25 plus 0.75. So option C is the right answer. Option C is the right answer. Option C is the right answer. Understood? Understood? Yes or no? There's also the easier way to do this. There's also the easier way to do this. How? You can see this is the point B across which you need to find out the impedance. Before the point B, you have a delta connection. So when you have a delta connection, there will be no zero sequence. Now always remember, when there will be a delta connection, there will be an open circuit. There will be an open circuit here. So if there is an open circuit here, then whole network has been disconnected in a zero sequence. So only what remains? Only the motor remains. So the motor impedance is nothing but a Thevenin impedance. Okay, but that you can gain once you have a good knowledge. So I understand this particular diagram you have seen. This is the zero sequence diagram. This is the zero sequence diagram. Okay. Next. Now let's talk about the transmission line. Let's talk about the transmission line. We have seen the alternator, we have seen the motor, we have seen the transformer, how they represent in case of positive, negative and zero sequence diagram. Now we'll talk about the transmission line. So in a transmission line, you have a three reactance, XS, XS, XM. You also have a mutual reactance. XM is what? Mutual reactance. This is mutual reactance and this is self reactance. This is self reactance. So what happened in case of positive sequence, the positive sequence is equal to XS minus XM. Positive sequence impedance is equal to XS minus XM. The negative sequence impedance is equal to XS minus XM. But a zero sequence impedance is equal to XS plus 2XM. So you just need to remember this. No need to go into a derivation. You just need to remember this. What is the positive, negative, and zero in case of a transmission line? In case of a transmission line. Understood this point? This you need to remember. Positive sequence, negative, and zero. It depends on XS and XM. It depends on XS and XM. For example, let's do this question. Let's try to do this question. They have given positive sequence impedance and zero sequence impedance. You have to find out imaginary part of Zm. You have to find out imaginary part of Zm. Try करो ये अच्छा question है. This is a previous year question. Okay. Try this one. If you have any doubt, you can ask, because I can see only few students are there who are asking and giving the answer. I'm expecting everybody to at least try it and give the answer. I'm expecting everybody to try it and give me the answer. See very carefully. We have given the positive sequence impedance now. So positive sequence impedance is equal to Zs minus Zm. Whereas zero sequence impedance is equal to Zs plus 2 times of Zm. What we need to find out? We need to find out Zm here. So if I subtract Z0 and Z1, I will get Zm. If I subtract Z0 minus Z1, so 2 times of Z1, no, 3 times of Zm. So Zm comes out to be Z0 minus Z1 divided by 3. It comes out to be Z0 minus Z1 divided by 3. So Zm is equal to, what is Z0 here? 4 plus J31 minus 1 plus J10 divided by 3. You will get 1 plus J7. 1 plus J7. They are asking imaginary part. So imaginary part कितना हो गया? 7. Imaginary part is 7. How it is 1? It is a real part. They are asking the imaginary part of Zm. They are asking the imaginary part of Zm. You can join this Telegram channel, बच्चों. You can search and join this Telegram channel. J13 लिया मैंने. Why you have taken J13 बच्चे? मैंने, है ना? Simple question, ना? It's a simple question. So Sonia, you can ask, and everybody else, you can join this Telegram channel also. Posted out and anything else here. I will upload PDF here also. For yesterday's class, for network marathon, I will upload the PDF there, and also for today's PDF. Next. Now try to solve this one. Try to solve this one. Okay, that you can solve by yourself. Now you know the formula, na? You know the formula. You can solve it by yourself. Don't worry. Now let's talk about fault. Let's talk about fault. Let's talk about fault here. What is the fault actually? Fault is the abnormal condition that occur in a system in which the high current at a low voltage will pass through the system. In which the high current at low voltage will be passed through a system. For example, I have a system like this. For example, I have a system like this. Okay. Now let's suppose the lightning occur. Let's suppose here the lightning occur. Now because of the lightning, the fault will occur. Because of the lightning, a fault will occur, or not lightning, you can say a tree fell down. For example, a tree fell down on a transmission line and then it is connected to a ground. It's a very practical situation. A tree fell down on a transmission line and connected to a ground. So in that case, the particular transmission line is become connected to a ground. It means the fault occur. Now it provides a least resistive path. If you see the fault path, if you see this fault path, it is approximately equal to 0. Approximately equal to 0. It can also more than 0, but it is the least impedance path we have. So what will happen? The generator will supply the fault current. The generator will give the current. The motor will also give the current, because motor has a tendency to act like a generator when the excitation change. So motor has a tendency of that. So the synchronous generator, both will give the fault. Then the total fault current will be equal to generator current plus motor current, and that's why the magnitude of fault current increased a lot. The magnitude of a fault current increased a lot, whereas voltage at fault point is minimum. Voltage at fault point is minimum, approximately 0. Voltage at fault point is minimum, but the resistance is very high. Now if you go away from the fault point, if you go away from a fault point like here and here, the voltage will keep on increasing, but the current will keep on decreasing. Okay, so this is a simple basic things that you should understand, but there are also more of the points that we can discuss. But we are basically here to solve two kind of fault. One is symmetrical fault and one is asymmetrical fault. Now what is a symmetrical fault? Symmetrical fault are of three types: triple L fault and triple L to ground fault. The characteristic of symmetrical fault is that if this kind of fault occur, the system remains the balanced system. The system not become unbalanced. This is the most important point here. Whenever the symmetrical fault occur, the system remain balanced, and when the unsymmetrical fault occur, the system remain unbalanced. So in a symmetrical fault, we have a triple line fault. It means the fault occur at all the three lines or all the three phases together. Next, we have a triple LG fault. It means the fault occur and a three line and connected to a ground. So let's talk about first triple L fault. Triple L fault means the fault occur at all the three phases of a system together. All the three phases of a system together. This is a fault. This is a fault impedance. This is a fault impedance, and all the phases together. So this is known as a simple diagram of triple L fault. This is a simple diagram of a triple L fault. This is a simple diagram of a triple L fault, that the fault occur on all the three phases together. IA, IB, IC. Fault occur on all the three phases together. For example, a tree fell on three-phase transmission line. Then it will connect all the transmission lines together, all the phases together. Then it is known as the triple L fault. Now in each and every kind of fault, what you need to remember? You need to remember conditions, and you need to remember the fault current equation. Also, you need to remember the circuit diagram. These three you need to remember. Then you can solve each question of fault very easily. For example, in case of a triple L fault, the fault current is equal to 1 upon Z1 plus ZF. 1 upon Z1 plus ZF. Now, this is actually, we are talking about per unit system. 1 upon Z1 plus ZF. What is Z1? Z1 is actually a positive sequence impedance. Z1 is positive sequence impedance, whereas ZF is the fault impedance. Okay, so in triple L fault, the formula is very, very simple. It is 1 upon Z1 plus ZF, and this you need to remember. Okay, this you need to remember. Now here also, IA1. What is the IA1? IA1 is going to be IF, and obviously if you talk about the negative and zero sequence, they will not be present here because system is balanced. So they will not be present here. So in case of triple L fault, this is the fault current formula and this is IA1. Simple concept, very simple concept. Now if you talk about triple L to ground, three-phase fault, simple fault current you need to remember. Fault current is equal to IA1 is equal to 1 upon Z1 PU. Again, this is in a per unit system. And what we have find out? Obviously, IA2 is 0, IA0 is 0. Okay, understood this point? Yes or no? If you have any doubt, you can ask. Now, here you can note one point also. That if you want to find out fault current actual value, what you have to do? Fault current in per unit, multiply by the base current. So in the question, you have to remember very carefully how to remember. Beta 3 is the formula. Rajesh, there's only 3 formulas. You have to remember that there's no shortcut there. One thing you can do, you can remember the circuit diagram. If you remember the circuit diagram, then the number of formulas will become half. Okay, that I will discuss. Okay. So if you want to find out the actual fault current, it will be the per unit fault current multiplied by the base current. Per unit formula is given here and also given here. Simple. Any doubt here? Okay. Now one more point. General point. Short circuit MVA. It means short circuit MVA means what will be the power delivered to the fault during the short circuit or during the fault. Whatever the power delivered to a fault, the name is short circuit, but it is also applicable for the unbalanced fault also. So whatever be the power that will deliver to the fault point, that is known as the short circuit MVA, and based on this rating, we actually choose the circuit breaker. Based on this, we actually choose the circuit breaker. Okay. So what is the short circuit MVA? Short circuit MVA is equal to short circuit per unit multiply by base voltage, base power, multiply by base power. Now what is short circuit per unit? It is equal to I1 PU multiply by the base power. So this formula you need to remember. This formula will be applicable for every kind of fault. This formula is applicable for every kind of fault, whether it is a symmetrical or asymmetrical fault. This formula is applicable. So if they are asking you what is the short circuit MVA, first you will find out the fault current. You find out the IA1. In a balanced fault, it is very much easier to do this because fault current and IA1 both are same. Fault current and IA1 both are same in case of a symmetrical fault. When you go into an unsymmetrical fault, the fault current and IA1 will be different. So this point you need to understand here. And in a short circuit MVA, you only need to use the I1 per unit, which means positive sequence current multiplied by the base power. Okay, any doubt here? Tell me. Also tell me why we are using a positive only, why not negative or zero? Why we are using positive only, not negative and zero? Anybody think about it? We are using a positive only. Bacho, because in a positive sequence network, only you have a voltage source. a negative and a zero sequence network, you don't have a voltage source. That's why. Okay, base power. Next. Now let's talk triple algebra. We have seen. Okay, fine. Let's talk about unsymmetrical fault. So in an unsymmetrical fault, you have to draw the sequence network. You have to draw the positive sequence network, negative sequence network, and a zero sequence network. And then you have to combine this sequence network according to each fault we have. For example, in case of LG fault. What happened? Let's talk about LG fault. So this is the line to ground fault. Now what happened in line to ground fault? See very carefully. Let's suppose the fault occur at phase A. If the fault occur at phase A, the current in phase B and phase C is zero. The current in phase B and phase C is zero. Why? Because always remember, we do the fault analysis. Remember this point. We do the fault analysis at no load. We do the fault analysis at no load. Okay? So since there is no load connected here, when the fault occur at phase A only, so current in phase B and phase C is zero. So one thing I can write down here, current in phase A is equal to fault current. Current in phase B is 0. Current in phase C is equal to 0. So here you can see you have an unbalanced system. This forms the unbalanced system. Do you understand this point? This forms the unbalanced system. IA, IB, IC. Now if you have a IA, IB, IC, can you find out the positive, negative and zero sequence current? Yes, you can find out. Kaise? Using this formula, IA0, IA1, IA2. You can find out these currents 1 by 3, 1, 1, 1, 1, 1, alpha इसका होगा 1, 1, 1. 1 alpha, alpha square, alpha. IA, IB, IC. IA, IB, IC. IA, IB, IC. Now, here you can see IB is 0, IC is 0. So, IB is 0, IC is 0. So, if you put IB, IC 0 here, IB is 0, IC is 0, IA is actually equal to fault current. So, you will find out IA0 is equal to IA1 is equal to IA2 is equal to fault current divided by 3. Is equal to fault current divided by 3. From here, you can find out that fault current is 3 times of IA1, and this you need to remember. That fault current is 3 times of IA1 in case of LG fault. Whereas in case of triple L fault, we have seen fault current was equal to IA1. Here the fault current is equal to 3 times of IA1. Now here you can see all the phase sequence current are equal. The positive phase sequence, negative phase sequence, zero phase sequence, all the phase sequence current are equal. Now these can only be equal if these networks are connected in series. If these networks are connected in series, then only the current become equal through all the networks. That's why in case of LG fault, you will find out that positive phase sequence network, negative phase sequence network, and zero phase sequence network, all of these three networks are connected in series. Yes or no? Understand? So this you need to remember again. Then all the three phase sequence are connected in series. Now if they are connected in series, can I find out IA1? If all of these are connected in series, so IA1 is equal to 1 divided by 1, as you will say EA, divided by Z1 plus Z2 plus Z0 plus 3 times of Zn plus 3 times of Zf. Like this. You can put like this. Or you can say IA1 in per unit. IA1 in a per unit. 1 divided by Z1 plus Z2 plus Z0 plus 3 times of Zn plus 3 times of Zf per unit. So this is the formula of IA1. Now what is the fault current? I told you 3 times of IA1. This is the fault current. What is the short circuit per unit? That is equal to IA1. What is the short circuit MVA? Short circuit per unit multiplied by the base power. This becomes this. Understood? Yes or no? What you need to remember? You need to remember this. You need to remember this. You need to remember this. No need to remember this, because once you have a circuit, you can calculate IA1. It is easy. You can calculate IA1. It is easy. है ना? Everything is connected in series. Any doubt here? Next question we will do after some time. First, let's discuss the line-to-line fault. Now, what happens in case of line-to-line fault? In a line-to-line fault, the fault occur in two lines. The fault occur in two lines, and the fault impedance are connected here. Now, what are the conditions here? What are the conditions? The fault occur in line B and C. So IA is going to be 0. IA is going to be 0. Now see very carefully. This is IB equal to fault current. This is IC equal to minus of IF. So can you write down this? Can you write down like this? IC is equal to minus IB is equal to IF. You can write down, or you can say, हाँ. ऐसे इसको कैसे लिख लो? ऐसे लिख लो इसको. IB equal to minus IC equal to IF. IB equal to minus IC equal to IF. Write down. You can write down this way. IB equal to minus IC equal to IF. Yes or no? Yes or no? What is V by VB, बच्चे? Rajesh, what is V by and VB? So you can write down this form. Now again, you can find out a fault current, but I'm writing the formula directly. No need to go into a derivation. No need to go into a derivation. You can just remember the formula directly. No need to go into a derivation. You can just remember the formula directly. So this is the per unit. This is the per unit. This is the per unit formula. For example, in the line-to-line fault, the formula was 3 times of IA1. What should I say? IG means? IG means line to ground. Achha, okay. Line to ground. Tell me, beta, what's the problem in line to ground? Yeah, line to ground. Fine. Line to ground. You have a notes now, Vinay. You already have a notes now. You can go through that notes also. If you're writing this, then there's no use now. You already have a very well maintained notes when I teach you now. So you already have notes. Right now we are revising these things. Although I've told you derivations and all, everything. So IF is equal to root 3 times of IA1 minus 90. Now one thing you need to understand or remember into line-to-line fault. One thing you need to remember in line-to-line fault, that IA naught is 0. IA naught is 0. The zero sequence current is 0. The zero sequence current is 0. If the zero sequence current is 0, there will be no zero sequence. There will be no zero sequence network. If the zero sequence current is 0, then there is no zero sequence network. There will be only positive and negative sequence network. There will only the positive and the negative sequence network present. That's why here you can see we only have a positive sequence network and the negative sequence network, and both of them are actually connected in anti-parallel. Both of them are actually connected in anti-parallel. See the direction? IA1 is going, IA2 is going. Okay? Understand this one? Yes or no? This you need to remember, anti-parallel connection. So here, what you need to remember? This diagram, the fault current, root 3 IA1 angle minus 90. This you need to remember. IA naught is 0. This you need to remember. This you need to remember. Now from here, can you find out IA1? From here, can you find out IA1? कैसे find करोगे? It's a simple network. It's a simple network theory. The Z2, ZF and Z1. So try to find out IA1. Try to find out IA1. Here, Rock, why you want arcing ground? Where you see, have you seen any question based on arcing ground except in 2012? There is a 1 mark question. Apart from that, have you ever seen the question based on arcing ground? So from here, IA1 is equal to EA divided by Z1 plus Z2 plus ZF. Enough. If you talk about in a per unit, it will be 1 divided by Z1 plus Z2 plus ZF per unit. Right now, when the exam is near, try to do only those topics which are important for exam. Arcing ground is not important for GATE because they ask only one time, and they only ask on the theory, what is arcing ground. Apart from that, there's never ask about that. So why you are worried about it? Now you can worried about these topics after the exam. What is arcing ground? What is lightning arrestor? Yeah, what are different protection systems that you can think about it. But right now, just focus on the syllabus that is coming into your exam, right? Because your goal is to get marks right now. Your goal is not getting knowledge right now. For the knowledge, you had a complete year. But for now, for the marks, this should be your goal. Remember, everybody, not only here Rock, everybody should remember right now your particular goal should be of getting marks, not knowledge. Okay, knowledge ke liye you had a complete 1 year. Now, okay, so this is the IA1 per unit. So no need to remember this one. If you remember this circuit diagram, then you can easily find out this using the KCL, KVL. Okay, so in the examination, line to line fault, line to ground fault, three-phase fault. These three faults are important, and 99% question based on fault will come only from these three questions. Short circuit MVA same. I told you now, it's going to be same. Short circuit per unit is equal to IA1. So short circuit MVA again same. It is same for every fault. Yeah. So understand this point. These three faults are important. The double line to ground fault, the question will rarely come, because in double line to ground fault, the calculation is very large. Okay. So what happened? Double line to ground fault. The fault occur in IB and IC together, and they are connected to a fault impedance. So here you can see IA is 0, but IB plus IC is equal to fault current. One more condition you can remember here, that VA0, VA1, VA2 is equal. Matlab voltages of every phase, voltages of every sequence network is equal. If voltage of every sequence network is equal, it means we have a parallel connection. That's why in the diagram you see you have a parallel connection here. See very carefully. That's why you have a parallel connection here. This is a positive phase sequence. This is the negative phase sequence. It is a zero phase sequence. But here, the fault current in this case is equal to IA0. This you need to remember. Fault current in this case is equal to IA0. 6.1 CGPA है क्या MTech IIT admission के लिए eligible है? Beta, for a CGPA I am not sure, but in a percentage your minimum should be 65%, but try to maintain above 70. Okay, if in a CGPA form I don't know. So the fault current in this case is equal to IA0. In earlier cases, the fault current depends on the positive sequence current, but here the fault current depends on only the zero sequence current. Now here you can find out the zero sequence current. Kaise? You can see network theory. IA1 is a current coming. And it is dividing into two branches. So by using a current division rule, you can find a current in IA0. Yes or no? Let's do it. So I can say here, what is IA1? 1 divided by Z1 plus Z2 parallel to 3 times of ZF plus Z0 plus 3 times of Zn. Like this, you know? So IA0 is equal to minus IA1 multiplied by Z2 divided by Z2 plus Z0 plus 3 times of Zn plus Zf. Again, no need to remember this formula. You need to remember this. This diagram. Once you remember this diagram, you remember the fault current. Then you can find out IA1, IA0 using the network analysis. Nothing else. Understood this point? Yes or no? Understood this point? So let's solve one form. For example, this simple question. A fault occur. Which kind of fault is here? They're asking which kind of fault is here. See, very simple question. Check the conditions. You can give the answer easily. without worrying about anything. You just check the condition and you can give the answer easily. Which fault occur here? Which fault occur here? You can see VA0, VA1, VA2. All three voltages are same. Double line to ground fault. This happen in case of double line to ground fault when the all positive sequence network is same. Double line to ground fault. 3 times of IA0. That is also true. That is also true. But you can see the voltages also. Because all the 3 sequence voltages are same. So we have a double line to ground fault. Okay. One more question we will solve. Okay. Try to solve this one. Try to solve this one. No, that was not LG. That was double line to ground. That was not LG. That was a double line to ground. Try to solve this one. Be very careful. The severity of line to ground fault and the 3-phase fault, correct Prash? 3-phase fault at a terminal of an unloaded synchronous generator is to be same if the terminal voltage is 1 per unit and the Z1, Z2 and Z0 is given. The required inductive reactance for the neutral grounding is. So we have two kind of fault here, LG and 3-phase fault. So if you talk about a 3-phase fault, what is the fault current? Fault current is equal to IA1. IA1 is equal to 1 upon Z1. 1 upon Z1 because fault impedance is not given. Fault impedance is not given, so I can take 1 upon Z1. Now, if you talk about line to ground fault, in this case, the fault current is equal to 3 times of IA1. Now, since in case of LG fault, all are connected in series, so it will be 3 multiplied by 1 divided by Z1 plus Z2 plus Z0 because all 3 sequence networks are connected in series. Since the neutral is asking, and I told you, for neutral, there will be 3 times of Zn. Now, according to question, they have said the severity is same, shayad, both of these are same. So 1 upon Z1 is equal to 3 divided by Z1 plus Z2 plus Z0 plus 3 times of Zn. They are same. So let's put every value. Z1 कितना है? 0.1, 0.1, 0.05. 1 upon 0.1, 3 upon 0.1 plus 0.1, 0.05 plus 3 times of Zn. This you need to find out, है ना? So 0.25 plus 3 times of Zn equal to 0.3. Zn comes out to be 0.05 divided by 3. Check the calculation once. No, correct. Option A. You know, 0.01. Maybe there is one extra 0 here. If I'm not wrong, there is one extra 0 here. You know? There is one extra 0 here. 0.0166. Okay. So in this way, you can solve this question. It's just a 2-mark question. It's a 2-mark question. So if you understand the formula correctly, you can solve the question easily. Take this in your homework question. Try to solve it. Take the screenshot, everybody, and try to give the answer in a comment section. Okay, after the video. So it's a very good question. Take the screenshot. Let me check. Is there another question left? Okay, try to solve this one. I can see the dip in the attendance. There's only few students left. That's why we don't want कि हम power electronics and networks ka le. Because the same thing happened. There were students come in a starting, but when the session become longer, then many students leave the session. And it will demotivate it because here we are just teaching you continuously, and when you start leaving the class, that feels bad. And it happens when you have a core subject. when you have a core subject. This generally happens. So a three-phase star-connected alternator is rated this and this and has the following phase sequence. The neutral of the alternator is solidly grounded. Determine the current in phase B when a double line to ground fault occurs to its terminal. Assume that the alternator is unloaded and operating at rated voltage. So they are asking, we need to find out current in phase B. Okay, it is written then okay. If it is written on a 6 CGPA on a scale of 0 to 10, then it's okay. Because on CGPA basis, I don't know. Now let's talk about this question. They're asking what is the current in phase B? Phase B. So in a phase B, I can find out a current like this. It is IA0 plus alpha square times of IA1 plus alpha times of IA2. So I need to find out IA0, IA1, IA2. Once I find out these three, I can find out current at phase B. Okay, fine. Okay, let's see. So we have given x1, x2, x0, and they have said solid ground. Solid ground means what? Solid ground means that xn equal to 0. Okay, solid ground means xn equal to 0. So we just seen the circuit diagram here for a for a double line to ground fault. For a double line to ground fault, understand here. For a double line to ground fault, all the three. This is the positive sequence network. This is the positive sequence network. It is 0. It is negative. It is 0. All are connected in parallel. This is IA1. This is IA2. This is IA0. Now we can find out the values. I'm not going to do the calculation here because that you can do it by yourself. But now you can find out a value. Kaise? IA1. What is going to be IA1? 1 divided by x1 plus x2 parallel to x0. है ना? See very carefully. x2 and x0 and x1 all are given. So I can find out the IA1 here. If I have a IA1, I can also find out IA0. But see very carefully, the direction is opposite. IA1 and IA0 direction is always opposite here. So we have to use the minus sign. So we have to use the minus sign here. So minus IA1 multiply by x2. Sorry, x2 divide by x0 plus x2. Finally, if you want to find out IA2, it will be IA1. So, see, for IA2 you can apply the KCL. So IA2 plus IA1 plus IA0 is equal to 0. You can apply the KCL. So from there, you can find out IA2. Now, once you have IA1, IA2, IA0, you can find out base current also. You can, sorry, not base current, IB. You can find out current in phase B. Understood? Try to understand the concept behind this question. Although the question based on double line to ground fault, the chances are very less. But if the question comes, the calculation will be simpler. For example, here you can see you only have a three reactance here. So calculation is much simple as compared to the fault it has. Any doubt in this question? You can do the calculation by yourself. Otherwise, the time will be wasted here. Nothing more than that. Yeah. So guys, tell me, do you want a break or should we start next topic? Because we complete the fault. So tell me by voting, do you want break or should we start the next topic? Z bus and Y bus. Because one question will definitely come. On the Y bus and Z bus matrix. Arun said no. Rest of the students, tell me. No, not till now. I will upload it today. After today's session, around, I guess, 9 p.m., 11 p.m. I will upload it. Order of chapter, sir. We have done the fault. This is half an hour topic. Matrices is a half an hour topic. Then we will do the stability. Then we have distributors. And then I will do inductance and capacitance formula. But I'm thinking, since the time is less, I'm thinking, क्यों ना after matrices, after matrices, we should do the inductance and capacitance. GMD and GMR. How to find out GMD and GMR? That is important. The question, the high chances the question will come. So I'm thinking that after matrices, we will do the inductance and capacitance, because we can do those topics earlier. Na? That is a very high chance to come. And after that, we can do the distributor and then stability. That we can do it, you know, right? Because there is because we have already done the fault analysis here, so 3 marks will be definitely come from those particular topic. Then there will be a 2-mark question, 1-mark question from inductance and capacitance, so that we will deal after matrices. So I can see more students are talking about break. Okay, we will take the 20 minutes break. We will take the 20 minutes break. Ashok, the point is, if I no, Arun, the point is, if I take stability right now, na, the stability consume 2 hours directly. So if stability consume 2 hours directly, na, what happen? All the other chapter will left. Think about it. From the stability, you have a 3 marks, है ना? From matrix, you have 1 mark. From matrices, you have a 2 mark. From here, you have a 3 mark, 2 marks, and here you have a 1 marks. So here you can see you have a 5 marks window here, 5 marks window here, and a stability. What happened? In that 2 hours, we are not going to cover all the topics here, because there are many topics. You can only see the steady state stability. In a transient stability, there are multiple cases there. You know, that's why I will plan one class on a stability in the next week around. Okay. So we will take a break of 20 minutes right now. So let me write down here. So we have a break for 20 minutes. But I will expect all of you. I expect all of you to come on time. Don't be late. I expect all of you to come on time. Don't be late. Okay. So 1:10, 20 minutes break. Hai. You can take a lunch and anything else you can. But be on time. Be on time. Okay. Okay, बच्चों. Fine. So hello everyone, are you back? So we are back again. We are back again with the next 2 hours. We are going to discuss more about power systems. So tell me, who is back? Who are live right now? Let's everybody join the session, and then we will start. We will start in 3 minutes. Good afternoon. Good afternoon. Okay, Vinay. Just wait for 2-3 minutes, and then we will start. Meanwhile, let me check the network issue once. Everything is correct. Okay. So you can join my Telegram channel. I will upload the PDF there of the power system and also the yesterday's class of network theory. Okay. So before where was we left? Where we left? Okay. Okay. Okay, let's everybody join the session and we will start. Share करो session अपने दोस्तों के साथ. So now we'll discuss about the concept of network matrices. So network matrices basically is a concept in which you have to create the Y bus and the Z bus matrix. Now why we require a matrix? The simple concept is that if we talk about the practical situation, in a practical situation there are large number of buses. In a practical situation there are large number of buses. Means if you talk about a practical situation, there can be a 50 bus system, 60 bus system, 70 bus system. Now in this type of situation where there's a large number of buses, you cannot do the calculation manually. You have to use the computer software, computer operations there. Now what happens in the computer operations? The operation will be done using a matrices. So actually we use the Z bus matrix and the Y bus matrix in a load flow analysis as well as in a fault analysis. In case of fault analysis, we use the Z bus matrix. In case of load flow analysis, we use the Y bus matrix. Okay. But the question based on these phenomena is a very, very rare chance that will come because the calculation part is quite large if you talk about NR method and Gauss-Seidel method. So if you do the calculation of NR method and Gauss-Seidel method, it will consume much amount of your time. So that's why in the examination, there's a very, very, very less chance that they may ask you anything about NR or the Gauss-Seidel method. So in this topic, we are going to understand how to create a Y bus and a Z bus matrix. Now from the name you suggest, Y bus is an admittance matrix and Z bus is an impedance matrix. So when you are creating a Y bus, all the elements must be present in admittance form. And when you are creating a Z bus, all the elements must be present in an impedance form. So this is the basic that everybody knows. Now let's talk about the Y bus matrix. So Y bus matrix is a very sparse matrix. It is a highly sparse matrix. A sparse matrix means that there is a. I have left NR and Gauss method. That's okay. Okay for gate examination. Even okay for other exams. But when you give the exam of ESC mains, then you have to do the NR and the Gauss-Seidel method. So if you talk about the Y bus matrix, matrix is actually the highly sparse matrix. A sparse matrix means number of elements present in the Y bus matrix is 0. Maximum number of elements present in a Y bus is 0. That is the meaning of a sparse matrix. Also, it is a symmetrical matrix. Now, what is actually a Y bus matrix? Let me tell you. So, in a Y bus matrix, simple phenomena is that we have to find out two values. We have to find out two type of admittance. One is a diagonal element. One is a non-diagonal element. For example, like this. We have to find out the diagonal element and the non-diagonal element. Now, always remember the order of this matrix is equal to n cross n, where n is number of buses. The order of this matrix is always n cross n. Now understand here how to find out a diagonal element. First of all, diagonal element cannot be 0. If there is a n buses, then there will be n diagonal elements. So diagonal elements can never be zero. First point. Next, in the diagonal elements, it is equal to sum of all the branch admittance directly connected to the bus I. In a diagonal element, it is equal to sum of all the branch admittance connected to that bus directly. For example, I have this. For example, I have bus 1. So what will be the Y11? Y11 is equal to all the admittance which is connected directly to it. Y20, Y12. This is the Y11. For example, I need to find out Y22 here. So Y22 is Y12 plus Y23 plus Y20 plus Y20. So this is the diagonal element. So to find out the diagonal elements, you just need to add up all the admittance which are connected to that particular bus directly. Nothing more than that. In case of non-diagonal elements, it is simple. Non-diagonal element means you need to check the admittance between two buses. For example, Y13. For example, Y13. It means the admittance connected between the bus 1 and 3, or the transmission line connected between bus 1 and 3. So it is equal to minus of the admittance connected between bus 1 and 3. Minus of admittance connected between the bus 1 and 3. Okay, simple logic. Simple logic. Understood these 2 points? Understood these 2 points? Now one more point. For example, I have Y11, Y12, Y13, Y21, Y22, Y23, Y31, Y32, Y33. Okay, so this is a 3 cross matrix, 3 cross 3 matrix we have. It is a 3 cross 3 matrix we have. Now what will happen? As you can see in the previous diagram, this is Y10. This is Y10. As you see in this diagram, this is the shunt branch. This is the shunt branch. It is also the shunt branch, and that is also the shunt branch. This is important. So there is a shunt branch which is connected directly to this bus number 1, bus number 2, and bus number 3. Now how to find out value of this shunt branch? So this shunt branch is actually equal to summation of all the elements written in a first row. So I can say the shunt branch of first one is Y11, Y12 plus Y13. Now the shunt branch connected to bus number 2 is equal to Y21 plus Y22 plus Y23. Similarly, shunt branch connected to a third bus is equal to Y31, Y32 plus Y33. So in this way, you can find out the shunt branches. If summation of each row is 0, if summation of any row is 0, if summation of any row is 0, it means there is no shunt branch. It means there is no shunt branch. Okay, understood this point? Enough. So these 2 points are very important to understand. Let's talk about the sparsity also. So let me check one thing. Let's talk about sparsity also. Sparsity means the maximum number of elements present in a matrix is 0. So what is the formula of sparsity? The number of 0 elements divided by the total number of elements. Now how to find out these two quantities? Total number of elements. So think about it. You have a n cross n matrix. So total number of elements will be n square. You have a square matrix of order n. So the total number of elements will be n square. Now from here, I can find out total number of non-zero elements. So kindly tell me, what will be the total number of non-zero elements? First of all, the diagonals cannot be 0. So the diagonals are equal to the number of buses plus what are the remaining think about the remaining transmission lines. See very carefully. If one admittance is connected if one admittance is connected between bus number I and bus number J, if one admittance is connected between bus number I and bus number J, so I can say Yij is equal to minus Y. Also, I can say Yji is equal to minus Y. I can also say Yij and Yji equal to minus Y. It means a single transmission line. It means a single transmission line actually counted as a two element in a matrix. It means a single transmission line is actually counted as two element in a matrix. That is because of the symmetricity. So that's why the number of non-zero element is equal to n plus 2 times of transmission line. Plus 2 times of transmission lines. 2 times of transmission lines. So what will be the number of zero elements? What will be the number of zero elements? The number of zero elements will be difference of these two, n square minus n plus 2 times of transmission line. Simple. And then you can calculate the sparsity. How it will be n by 2, Vinay? There will be no n by 2. For example, try to solve this question. We have given a power system network which has 50 buses and number of transmission line is 120. Then what is the sparsity of Y bus? This is the disadvantage of giving break. बच्चे आते नहीं वापस हैं. Solve it quickly. Sparsity here. First of all, total number of elements. If you talk about total number of elements here, total number of elements is equal to n square, which is 50 whole square. It comes out to be 2500. Now, number of non-zero element is n plus 2 times of transmission line. So n is 50 plus 2 times of 120. So it comes out to be 245. So the sparsity is equal to number of zero elements. So 2500 minus 245 divided by 2500 multiplied by 100. So what is the sparsity? 88.4? Correct. 88.4 percentage. 88.4%. Correct. So it comes out to be 88.4%. Okay. So simple question. This type of question come for 1 mark. Now let's solve one question in which we have to form the Y bus. Okay. So try to solve this question. Construct the Y bus of this matrix. Let me find out. This is bus number 1, bus number 2, bus number 3, bus number 4. So calculate the Y bus of this matrix. What is the name? 245. What you are saying? Acha, 295. Acha, 295. Correct. 295. Construct the Y bus for the following network. So we have to construct the Y bus here. So how many buses are there? They have given you the 4 buses. They have given us the 4 buses. No, Rohit, the question also come from Z bus. The chances of Y bus is more, but the question also come from Z bus. But it is easy. Z bus is also easy. Just need to remember few formulas. Otherwise, Z bus is easy. So how will you construct the Y bus here? First of all, make a diagram. Bus number 1, bus number 2, bus number 3, and bus number 4 we have. From a bus number 1, we have connect this particular ZZ. ZZ is this one. So it become 1 upon J 0.2. Find out the admittance first. Everywhere. If you talk about ZT1 connected between bus 1 and bus 2. we have connect bus 1 and bus 2, ZT1, it is J0.1, it is J0.1, it comes out to be minus J10, it comes out to be minus J10. Then between bus 2 and bus 3, we have a line, so line is given 0.1 plus J0.3. So tell me what is the J0.3, tell me here what will come. Then between 3 and 4, we have a transformer Z22, which is J0.1. So again, between 3 and 4, we have minus J10. And these all are the admittance. Remember, these all are the admittance. Between the bus 4, Zm is given J0.2. So, okay, minus J5 hoga. It will be minus J5. Minus J5, it is also minus J5. So all of these are the admittance. Right? Let me solve 0.1 plus J0.3. Plus 0.3. 1 minus 3i. 1 minus 3i. This we will get. Yes or no? Yes or no? Right? So this we got. Now we create a matrix here. What will be the Y11? Y11. All the admittance connected to bus 1. All the admittance connected to bus 1. Minus J5 minus J10. So it comes out to be minus J5 minus J10. It will be minus J15. Y22. Y22 is all the admittance connect here. It will be minus J10, 1 minus J3. Minus J10 plus 1 minus J3. So it comes out to be 1 minus J13. Now, if you talk about Y33, so Y33 again 1 minus J3 minus J10. So it comes out to be 1 minus J13. Now, if I talk about Y44, then it is connected with minus J10 minus J5. So it comes out to be minus J15. So these are the principal diagonals. Zm is here. Zm is J0.2. So we have taken 1 upon J0.2 minus J5. Sorry. So these are actually the principal diagonal. Now non-principal diagonal. Non-principal diagonal. Let's see about non-principal diagonal. So Y12 is equal to Y21 is equal to minus of admittance between Y12. So if you check carefully, between 1 and 2 you have a minus J10. So it comes out to be J10. Okay? Now if you talk about between 2 and 3, so Y23 equal to Y32 is equal to minus of Y23. It comes out to be minus 1 plus 3J. Now if you talk about Y34 equal to Y43 equal to minus of Y34, it will be equal to minus J10. And apart from these, all the elements are 0. So if you write down the Y bus matrix, it will be Y11, Y12 is present, Y13 0, Y14 0. Y21 is present, Y22 is present, Y23 is present, and it is 0. Y24, Y31 is 0, Y32 is present, Y33 is present, and Y34 is Y34 is also present. Y34 is also present. If you talk about Y41, it is 0. Y42 is 0. Y43 and Y44 are present. So this will be the Y bus matrix. I will plan that for the remaining topics. I will plan for one more session. So this is the Y bus matrix. Okay, simple. Now next question. No, tell me the answer for this. Or I will do one thing. I can also plan the session on app. So there I will discuss the stability topic. On app also I will discuss the stability topic. But for that you have to Join the Telegram channel and I will tell you the session time there only. Solve this carefully. Solve this carefully. You need to find out the shunt elements and their nature. Shunt elements and their nature. So I just told you how to find out a shunt element. Just add all this admittance. Just add all this admittance. 15. It will give you minus J5. Minus J5. So tell me, is this inductor or capacitor? Is this inductor or capacitor? This is important point. Is this inductor or capacitor? Think about it. Think about it. Minus J5. Is it inductor or capacitor? Inductor, correct. We are talking about admittance here. Since the admittance here is negative, it actually represents inductor. Because we are talking about admittance, correct. Now, if you add these, so I guess 10, 20, 30, it will give you 0. No shunt element. If I add this one, so 13 minus J2. Again, I have an inductor. And if you add this, you will get plus J3. You will have capacitor. Simple. Inductor, capacitor. ये वाला अच्छा है. Next one is good. 2 or 3 times question has been come based on this type of phenomena. And this is actually for the 2 marks. So try karo. Correct, Pash. That was inductor and capacitor. 3 bus Y bus is given. If a new transmission line is added between 1 and 3, which is identical to the existing line, then find the modified bus. Think about it. So they have said one more transmission line has been added between the bus 1 and 3, which is identical to the older one. So it will change our bus matrix, so that they are asking. So always remember, in case of Y bus, if any transmission line is added or removed between 2 buses, then only those elements will be affected. Only those Y bus elements will be affected. It means between the bus number 1 and bus number 3, one element is actually connected. So only Y11, Y33, Y13 and Y31, all of this will change. And remaining will remain same. It means Y11, Y33, Y13, Y31. Only these 4 elements will change. The remaining elements remain same. So in case of Y bus, the modification is easy. You can remove or add the transmission line, and it will affect only 4 elements in a matrix. Okay. So first of all, find out what is the admittance which is connected between the line 1 and 3. So I can say admittance connected between the line 1 and 3 is equal to minus of matrix element of 1 and 3. So it is J5. So minus J5. So this is already connected. Yes or no? I can say this is already connected. Now what has happened? Between the bus 1, between the bus 3, already minus J5 admittance is connected. Okay. Now what we have done, we have connected one more admittance. We have connected one more like this. Minus J5. This is new. This we have connected. So first of all, tell me what will happen to Y13 new. Or I can say Y31 new. I can say this is the parallel combination, admittance will add. Yes or no? Sorry, my fault. Minus of Y13 total. So minus of minus J10. It comes out to be J10. Yes or no? Understand this point? Tell me guys, do you understand this point? Do you understand this point? Now what will be y11 new? Y11 new is equal to y11 old plus y13 new. So what is y11 old? What is y11 old? It is minus j15. It is minus j15. What you have done? You have add minus j5. You have add minus j5. So it comes out to be minus j20. Because what is y11? Addition of all the admittance which are connected. So this one is also connected. So add this one also. What is y33 new? What is y33 new? It will be y33 old and one more admittance connected between 1 and 3. One more admittance connected between 1 and 3. So y33 is how much? Minus j20. So it will be minus j20 plus minus j5. Minus j25. Minus j25. So I hope you get this point. है ना? Easier. Just understanding. Otherwise it is easy. So minus j20, minus j25, j10 and j10. Only these will change. Rest are same. Rest are actually same. This is the answer. Okay? Any doubt here? So modification in case of Z-bus is very much easier concept. Modification in case of Z-bus is very much easier concept. Yeah. Now let's talk about Z-bus matrix. Now Z-bus matrix, if you say, it's actually the inverse of Y-bus matrix, but you cannot find out inverse easily in case of 4x4 matrix, or when you talk about practical situation. In a practical situation, you have a 50x50 matrix, है ना? So you cannot find out inverse so much easily. Even your computer, your program will take much amount of time while calculating the inverse of a 50x50 matrix, or you can say the 100x100 matrix. It will consume much amount of time and power. So first of all, Z-bus matrix is used in a fault analysis, and also it is not a sparse matrix. If it is not a sparse matrix, it means it will consume large amount of memory. It will consume large amount of computer memory, because most of its elements are not equal to 0. Whereas in case of a Y-bus, it was a sparse matrix, so computer memory requirement was less because most of the elements were 0 there. Now in a Z-bus matrix, we have a simple sorry. In case of a Y-bus, we had a simple formula to calculate the Y-bus matrix. You have a network, you can inspect that and you can form the Y-bus. But the Z-bus, the concept is not that much simple. If I give you a network and just by adding the impedances, you can find out the answer. No, it is not easier in this case. That's why in Z-bus, we use the modification technique. And that is known as Z-bus building algorithm. In this, we use the technique of modification. So we are going to assume that initially we have some Z-bus. Matrix. Now, one by one, we will add the bus here. One by one, we add buses. One by one, we add the transmission line between buses. And then, according to that, we have a 4 type of modification we have. Now, modification 3rd and 4th is quite lengthy, or I can say modification 4 is quite lengthy. And that's good for your examination. That till now, in almost except of one question, they have asked the question based on type 1, type 2 and type 3 modification only. Type 4 modification will take some time, but the type 4 modification question has come only once in your power system exam. So let's discuss this modification one by one, and then we will take one example. So see very carefully. The type 1 modification. Type 1 modification tells you a new element is connected between a new incoming node and a reference node. For example, I have a network given. And this is the n cross n. It means it is a n buses. This is the n buses. Now type 1 modification tells you that one more bus will add in this network. Such that the transmission line will be between a new bus and a reference bus. A transmission line will be between the new bus and a reference bus. So if you add one more bus, then the order of bus will increase. For example, earlier you have a 9 cross 9 matrix because of 9 buses. Now you are adding one more bus. So obviously the order will increase and the order will become 10 by 10. So after type 1 modification, order become n plus 1 cross n plus 1, where n is the earlier number of buses earlier. Okay, so if you are bringing one more new bus there such that the impedance are connected between the reference, then this concept you have to use. You have an old bus, then you when the order of a matrix increase, it will increase one row and one column. So all the elements in a row and a column become 0 except the diagonal element. The diagonal element is equal to the new impedance. For example, we have given impedance matrix 1, 2, 3, 4. We have given this is the impedance matrix. Okay, now question, a new node, or I can say a new node is connected to reference. A new node is connected to reference with ZS equal to 3 plus J5. Then find Z bus. So we have already have one bus matrix, and the question is a new node is connected to a reference with ZS. So what we have to do? Very easily. The new Z bus, see very carefully. The order will increase. Earlier, the order is 2 by 2. Now, the order will increase. So, what you have to do? First, you have to write down this matrix as it is. Now, the order has been increased. It means one row and one column has been increased. So, this will be 0. This will be 0. This is 0. This is 0. Only this element will contain the new impedance, 3 plus J5. Only this element will contain the new impedance, 3 plus J5. Understood? Yes or no? Type 1 modification. Easy, yeah? Type 1 modification very much easy. Every element is 0 except the diagonal element. And diagonal element is a new impedance. Okay? Next, we have a type 2 modification. Now, in a type 2 modification, again, the new node is added, but that node is connected between the existing node, not the reference node. Type 1 was the case of reference node. But type 2 is a connection of new node with an existing node. That is the type 2 modification. So a new element is added between the new incoming node and the existing node. So again, the order become n plus 1 cross n plus 1. The order will increase. Now, how will the Z bus will modify? So let's suppose the new node is connected to ith bus. So see very carefully. When the new node is connected to ith bus, one row and one column will increase. Ith row will be copied here. There is somewhere here ith row. That is going to be copied here. Ith column will be somewhere here. So that ith column will be copied here. And the principal diagonal element is equal to Zii plus the new impedance that has been added. So this is the type 2 modification. Again, it is the easier modification. Yeah? Type 2 modification. Any doubt till now? For example, so, for example, a new bus, bus number 3 is connected to a pre-existing bus number 2. So it is a type 2 modification. So a new bus is connected to bus number 2. Earlier, the Z bus for the 2 bus system is given. So what will happen now? See very carefully. The new Z bus is equal to, first of all, write down the old Z bus. Now, see very carefully. It is connected to the bus number 2. So the second column, second row. So the second row will be copied as it is. The second column will be copied as it is. And here it will be Z22, this one, 4 plus the new impedance, 4 plus J 0.2, 4 plus J 0.2. Understood? Yes or no? Understood? Yes or no? This is a type 2 modification. Type 2 modification. Now go to a type 3 modification. So in a type 1, type 2, the node has been increased. The node has been increased, or I can say the buses has been increased. Number of buses has been increased. Type 3 and type 4, the buses remain same, because what happened? In case of type 3, a new element, or you can say impedance, is connected between the existing bus and the reference bus. For example, this is the N bus is given. This is the N bus is given. A new bus is a new element. A new element is added between the ith bus and the reference bus. There is no new bus added here. There is no new bus added here. So the order remains same. So the order remains same, N cross N. Order remains same, N cross N. Just a element is connected here. When a type 1, but type 1 was easier, na? Type 1 में क्या था? Type 1 तो easy था. Type 1 is easy. When you are adding a new bus with a reference, when you are adding a new bus with a reference, a new column and a new row will come out. All the elements in new column and new row is 0 except the diagonal element, which is equal to the new impedance. Type 1 was the easier one. है ना? Understood? Yes or no? A new column and a new row will add, and every element is 0 except the diagonal. Now, in a type 3, what will happen? In a type 3, a new element is connected between the pre-existing bus and the reference bus. In this case, you have to remember this formula. In this case, you have to remember this formula. You have to remember this formula. What is the formula? Z bus new is equal to Z bus old minus I plus ZS. I and S क्या? ZS is the new element. ZS is the new element, and ZII is a diagonal element. Is a diagonal element. ठीक है? Then you have a ith row, ith column. You have a ith column. You have a ith row. You have a ith column and you have a ith row. Then you will multiply it and solve this. When you multiply it and solve this, so the answer is the remembering of this formula is easier. What you have to do? Just Z bus old minus 1 upon ZII plus ZS and multiplication of ith column and ith row. What is the ith column and row? Ith is the bus at which the new element is connected to the reference node. Understand this? Now type 4 modification. In a type 4 modification, a new element is connected between pre-existing buses. For example, we have done the Y bus question right now, in which between bus number 1 and 3, a new element is connected. So if that was a Z bus question, that will come for the type 4 network, type 4 modification. So the same things happened here. Between the ith and kth bus, a new element is connected. Between ith and kth bus, a new element is connected. For this, you have to remember this formula. And yes, this formula is little bit long. But the good thing is that there's a rare chance the question will ask on this. What is the formula? Z bus new minus is equal to Z bus old minus 1 upon Z11, Zii, Zkk. These are the two buses. Between them, a new element is connected. Plus Zs plus 2 times of Zik. ठीक है? Multiply by ith column minus kth column matrix, ith row minus ith column matrix, ith row minus kth row matrix. For example, you have these columns 2, 3, 4, 5, 1, 2, 3, 4, 5. And between bus number 1 and between bus number 3, a new element is connected. So ith column, मतलब this and this, subtraction. 2 minus 1, 3 minus 2, 3 minus 5. This matrix. And also row, मतलब this row and this row. So if you subtract this thing, you will get 2 minus 3, 4 minus 4, 1 minus 5, like this. And upon them. Okay. So remember this formula. It will help you if the question will come. Because if the question will come, that will come for 2 marks. Okay, chances are less, but if remembering is not that much difficult. Okay, so let's solve one question over this. So we have to find out Z bus of this matrix. We have to find out the Z bus of this matrix. First of all, number of buses are 4. So obviously the order of a matrix will be 4 by 4. Okay. Now we will find out a Z bus using a modification technique one by one. Okay. So let's see. Let's see very carefully. Step 1. Step 1. This is a reference node and this is a node 1. This is the reference node, this is the node 1 and Z1 is connected. Okay? Now think about it. Which modification is this? Which modification is this? This is the type 1 modification. This is the type 1 modification. Why? Because a new node 1 is connected to the reference node. A new node 1 is connected to a reference node. So it is a type 1 modification. There is only single node here. We don't count reference node. There is only a single node here. So that single node will only present in the Z bus. So can I say from here the Z bus is equal to Z1? From here I can say Z bus is equal to Z1. Simple. Because only a single node is present. Don't count the reference. So it will be Z1. Okay. Now step 2. This is already present. This is already present. Now I'm adding the bus 2 with the bus 1. I'm adding a bus 2 with a bus 1. I'm adding a bus 2 with a bus 1. Which type is this? 1, 2, 3, 4. Which type is this? Type 1, type 2, type 3, type 4. Bus number between 2 and 1. Between 2 and 1. It is type 2. It is type 2. It is type 2. Why? Because a new bus has been added with the pre-existing bus. With a pre-existing bus. The bus number 1 is a pre-existing. Now what happened in that case? The order of Z bus increase. The order of Z bus increase. So first of all, copy the previous Z bus. Copy the previous Z bus. And now, when the second bus is added to bus number 1, I require the ith first column and the first row. I require the first column and the first row. And this will be Z1 plus Z2. This will be Z1 plus Z2. Understand this thing? Understand this thing? Yes or no? Tell me, guys. Understand this thing? Type 2 modification. See very carefully. What happened in type 2 modification? First of all, write down the Z bus old. Then you have to write down ith row. Ith means the particular pre-existing node. In our case, it was first node. So first row, first column, and here it will be Z11 plus ZS. ZS is a new impedance. So the same thing we have done here. Oh, sorry. The same thing we have done here. Okay, fine. Now let's add 3. Bus number 3. So we already have this. 1, 2, we already have this. Hai na? Now I'm adding a bus 3. I'm adding a bus 3. Tell me the type here. Tell me the type here. Which type is this? Tell me the type here. I'm adding bus number 3. Bus number 3 to a reference bus. Bus number 3 to a reference bus. Bus number 3. It's a type 1. It's a type 1. When you add a new bus to the to the reference bus. New bus to a reference bus. So what will happen? In that case, the order will increase. So first write down the previous bus, which is Z1, 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 Z1 plus Z2. Now it is a type 1 modification. So new row and new column will add, but the value will be 0, 0, 0, 0, and the principal diagonal will be the new impedance that has been added. Principal diagonal is a new element that has been added. So it is Z3. Now the last is we have to add the node 4. We have to add the node 4. So this is 1, 2, this is 0, this is 3. The node 4 is connected between this. So 2 and 4, Z4. So this is the type. This is the type 2. Because a new node is connected to a pre-existing bus. But how it will be type 3 again? It is also type 2. Because a new node is connected with the pre-existing bus. So whenever the new node come, that will be a type 1 or a type 2. When in the pre-existing nodes element is added, then it will be a type 3 or the type 4. Okay? So what happened in this type? First of all, copy the previous bus. The order will increase. First of all, copy this bus. So it will be Z1 0. It will be Z1 0, Z1 plus Z2 0 0 Z3. Now in a type 2 modification, see very carefully. The bus number 4 is added to bus number 3. Bus number 4 is added to bus number, Bus number 4 is added to bus number 2. So I will take the second row and I will take the second column. So I will take a second row and copy the second row here. I will take the second column till of a previous bus. So Z1 plus Z2 and 0 and copied here. The principal diagonal will be this common element Z1 plus Z2 plus Z4. The new element added. So this becomes the Y bus. This becomes the Z bus. This becomes the Z bus of 4x4 matrix. Value you can put it by yourself. It is given in a question. Value you can put it by yourself. Any doubt here? Tell me. Any doubt here? Yes or no? Okay, good. This we will skip it right now. First of all, let me tell you one thing. Here. You can scan this QR code. Bachcho, and you will then you can directly participate in the quiz. If you haven't downloaded the app, so you have to first download the app and then you can get a quiz. One more thing, if you are not able to scan the QR code, the link is given in the description also. So don't forget to give the quiz. It will help you a lot. Also, here you can see that we have, if you are preparing for the GATE 25, you can give our scholarship test in which you can provide the 90% of the scholarship. Also, Rakesh is going to take session on 17th Jan on the 7 rules to ace the GATE 25 exam in first attempt. You can watch this session also. It's going to be live on 17th Jan on our app at 7:30 p.m. Okay. So there are few informations we have to give. Now I'm going to, and one more thing. This session of general aptitude, the date has been changed. Now the date is 14 and 15. Okay. Remember this. Although Rakesh has already communicated to you, but remember this, and this session is going to be important. Very, very important, bachcho. This session is going to be important because general aptitude, you have to score 15 by 15 or minimum to minimum, you have to score 13 marks because for the GATE examination, general aptitude level is very, very low compared to any other examination. So 13 marks you have to score, and that you can got simple. You can join this class and the Rakesh will tell you a lot about general aptitude. Okay, so let's talk about inductance. Okay, so we have a transmission line constant. What are constants we have? We have a inductance, we have a capacitance, resistance, and conductance. These are the transmission line constants. Constant means the value is fixed. So here the transmission line constant means the value of inductance, capacitance, resistance, or a conductance is not depending on the voltage or current. Whatever the voltage, whatever the current you provide, the value of inductance, capacitance of these four elements remains the same. That is the meaning of transmission line constant. Then on what parameter these values depend? This depends on the type of material. For example, you are using aluminium, you are using copper, it depends on that. It depends on the configuration, in which configuration you have put the conductors. It depends on the size and shape of a conductor. For example, you are taking a conductor of radius 2 cm, of radius 4 cm, and it also depends on the shape of a conductor. You can take the circular conductor, you can take the triangular conductor. So based on the physical appearance, based on the material, these parameters will change, but these are the constant based on the voltage and current. That does not depend on a voltage and current. Now right now I'm going to assume that you know about inductance, capacitance. I'm not going to that particular depth because it is a very basic thing. So I'm hoping that you know about inductance and capacitance. Right now I want to discuss with you the GMD and GMR concept. How to find out GMD and GMR concept, because when you are calculating inductance and capacitance, you have to find out GMD and GMR. Okay, so I'm not going into other things ki what is why the circular shape is happening, yeah, what is your corona effect, what is the skin effect. That's not important here, and you should already know about these things. Okay, so we can start about GMD and GMR. Tell me guys, should we discuss about GMD and GMR, how to find out these things in different cases? For example, 3-phase, single phase, bundle conductor, composite conductor, in case of a AC SR conductor, है ना? So we will discuss about these things, right? So first of all, what is the formula of inductance? What is the formula of inductance? It is equal to 2 into 10 raised to power minus ln minus 7 ln GMD by GMR Henry per meter. Similarly, capacitance formula is 2 pi epsilon naught divided by ln GMD by GMR farad per meter. So whatever the connection is given to you, you can use only these two formulas. No need to remember the formulas for each and every case. Just need to remember these two formulas, and you need to understand how to find out GMD and GMR. Once you have find out that particular thing, put here and solve the question. Okay, question will be simple once you understand the concept of GMD and GMR. Okay, so let's talk about GMR first. Let's talk about GMR first. Okay, what is GMR? GMR means geometric mean radius. First of all, geometric mean. What is the meaning of geometric mean? Let me tell you. For example, I have 4 numbers. 4, 1, 2, 3. The geometric mean of this number will be multiplication of all these numbers raised to power 1 divided by total numbers given. Okay, so here we have a 4 numbers, the power is 1 by 4 and multiplication of all this number. So this is known as a geometric mean. इसको क्या बोलते हैं? Geometric mean. ठीक है? So I hope this you know. So we can erase this part, geometric mean. Now let's talk about GMR. Now when you calculate inductance, or capacitance, you have 2 conductors. You calculate the inductance and capacitance between 2 conductors, right? Or you can say in a 3-phase circuit you have 3 conductors, or in a 3-phase circuit you have a double circuit line, so there will be a 6 conductor. But the inductance is always calculated between 2 quantities, right? That we know. Now when we calculate the GMR, we only see inside the conductor, inside a single conductor. We don't bother about what is going to happen in a second conductor. We are not going to bother about that. When you are calculating the GMR, you are only going to see the conductor for which you are calculating the inductance. Nothing else, only that particular conductor. For example, if you have a single conductor, like this. एक second. Wait a sec. My fault. Not single conductor, my fault. Let's suppose I have conductor A and I have a conductor B. I have a conductor A, conductor B. We have to find inductance due to A. So first we will calculate the GMR. When you are calculating a GMR, you only observe the conductor A. When you calculate the GMR, you only observe the conductor A. Now here you can see conductor A is a solid conductor. What is the meaning of solid conductor? The whole conductor is made up of single homogeneous material, for example aluminium. So this is the solid conductor. So conductor A is a solid conductor having radius r, so in this case GMR is equal to r dash. In this case GMR is equal to r dash, where r dash is equal to 0.7788 r. This you need to remember, where r dash is equal to 0.7788 r. So this we find out in case of a solid conductor. In case of a solid conductor. If you have a hollow conductor, in this case GMR is equal to R. In case of hollow conductor, the GMR is equal to R. Any doubt till here? So when you have a conductor, let's suppose conductor A, if it is a solid conductor, GMR will be R dash, or you can say 0.7788 R. When you have a hollow conductor, GMR is equal to R. Understood this point? Now, when you have a composite conductor, what is the meaning of composite conductor? What is the meaning of composite conductor? Tell me. Anyone. What is the meaning of composite conductor? First of all, I'm talking about single phase. I'm talking about a single phase, okay? So tell me, what do you mean by composite conductor? A conductor made up of number of subconductors. Composite conductor means the conductor which is made up of multiple strands, which not incoming outgoing. When you are talking about conductor A, let's suppose the current is entering here, so current will leave from the conductor B. Okay, it's not incoming outgoing. So when we talk about the composite conductor, it means we have a multiple stranded conductor. So let's take an example. Let's suppose I have a conductor A. In which number of subconductors present. 1, 2, 3. Let's n. The number of subconductors present. Let's suppose n subconductors are present here. So I need to find out GMR of it. Again, remember, when you are finding out GMR, you only need to see inside a single conductor. You no need to worry about कि B में क्या हो रहा है. You have to find out LA. No need to worry about conductor B when you are calculating GMR. Okay. So how will you calculate the GMR here? Let's see very carefully. The GMR of complete conductor A is equal to GMR of first subconductor, GMR of second subconductor, so on, GMR of nth subconductor raised to power 1 by n. We will find out GMR of each subconductor. And raised to power 1 by n. Okay. Now next point. Let's talk about GMR of 1. GMR 1 means distance of this subconductor by itself. D11. Distance of this subconductor with second. Distance of this subconductor with third. So on. Distance of this subconductor with nth. Raised to power 1 by n. Now what will be the GMR2? GMR2. Distance of second subconductor with first subconductor. Distance of second subconductor with itself. Distance of second with third. So on. D2n raised to power 1 by n. Yes or no? Any doubt here? Now finally, what is the GMR for nth subconductor? So n का 1 से, n का second से, and n का 3 से, and so on, n का खुद से, raised to power 1 by n. And out here. Now if you put all these GMRs into GMR A, then it becomes GMR A is equal to D11, D12, D1n, D21, D22, D2n, DN1, DN2, DNN. raised to power. We have 1 by n here and we have 1 by n here also. So raised to power 1 by n square. Raised to power 1 by n square. So this will be the GMR of a conductor A. This will be the GMR of a conductor A. And if you have any doubt here, you can ask. If you have any doubt here, you can ask. Think about it. If you have any doubt here, you can ask. If you have any doubt here, you can ask. Understood? Yes or no? जल्दी से बताओ. जल्दी से बताओ. Clear? Clear? Good. Good. Now there is one more point. There is one point. If there is symmetrical connection, if there is symmetrical connection, then GMR of composite subconductor, GMR of composite conductor is equal to GMR of single subconductor. So the line is, if there is a symmetrical connection, inside a conductor, it means number of subconductors are connected symmetrically. Then what happens? The GMR of a composite conductor is equal to the GMR of a single subconductor. For example, let's see example here. Let's see the example here. I have two subconductors here. Okay? This is the conductor here. This is the conductor A. Inside this, I have a subconductor 1 and subconductor 2. I have a subconductor 1 and subconductor 2. Okay? Now let's find out GMR of first. Let's find out GMR of first subconductor. It will be equal to D11, D12 raised to power 1 by 2. GMR of second subconductor, it is equal to D22, D21 raised to power 1 by 2. Now, what is going to be the GMR of complete conductor? It will be GMR of both subconductors multiply raised to power 1 by 2. Now, here you can see it will be D11, D12 raised to power 1 by 2. Here it is D22 or D21 raised to power 1 by 2. And here the complete raised to power 1 by 2. Now understand here. D11 and D22 are same. Actually, what is D11, D22? Let me tell you. DII is actually equal to R dash. So D11 and D22 are actually same. D12 and D21 are actually same. So can I say it will become GMR of A is equal to D11, D12 raised to power 1 by 2, which is actually equal to GMR of 1. So it means, understand this statement very carefully. It will help to reduce your calculation. If you have a symmetrical subconductors, then you need to calculate GMR due to only single subconductor, and that will be the GMR of the complete conductors. Okay, understand this point? On this point, let's talk about the bundle conductor. Bundle conductor is nothing but a type of a composite conductor. So let's talk about the bundle of three conductors. If you talk about the bundle of three subconductors. So a bundle of three subconductors are given. And the distance between them is S. Also, the distance between them is S and the radius is R. So when you talk about a bundle conductor, actually what happens, listen very carefully. This actually represents a single conductor. It's not a three different conductors, okay? Inside a single conductor, you have a three subconductors here. Now here you can see, I need to find out GMR. So you can see it is a symmetrical image. So GMR will be equal to GMR of first subconductor. GMR of a first subconductor. What is the GMR of first subconductor? वन का डिस्टेंस खुद से r डैश, वन का डिस्टेंस 2 से s, वन का डिस्टेंस 3 से s, raised to power 1/3. So this is the GMR of this bundle conductor. This is the GMR of this bundle conductor. Understood? Yes or no? Understood? Yes or no? This is the GMR of this bundle conductor. Tell me guys. Tell me guys. Have you understand this point? Have you understand this point? Ki how to find out GMR of a bundle conductor? So it's a bundle of 3 subconductor and GMR is equal to GMR of 1. Okay. Now if you talk about bundle of 4 subconductor, bundled of 4 subconductors. For example, like this. In a bundle conductor, the distance between them is same as S. This is S. This is S. Okay. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now very easy. Very easy. GMR of this complete conductor is equal to GMR of first subconductor. So I can write down distance of 1 by itself, 1 by 2, 1 from 3, 1 to the 4, raised to power 1/4. So D11, the distance with itself is R dash. D12 is S. D13 is also S. But what is the distance between 1 and 4? It is a diagonal of a square. Distance between 1 and 4, it is a diagonal of a square. So it will be root 2 times of S raised to power 1/4. So it comes out to be R dash S cube root 2 raised to power 1/4. So this is the GMR of this subconductor. One more thing. In case of bundle conductor, let me write down. In case of bundle conductor, GMR is known as self GMD. GMR is known as self GMD. So if in the exam they ask you to find out self GMD, so they are asking just the GMR in the bundle conductor. They are asking just the GMR of a bundle conductor. So in this way, you calculate the GMR in a different cases. We have discussed the solid, hollow, composite, bundle conductor. Solid, hollow, composite, bundle conductor. All of them is a single phase. One more thing. If the question will come to find out the capacitance, so where we have put the R dash now, every R dash become R. Let me write down this point. Point here. In case of capacitance, replace R dash with R. Okay, understand this point. For example, you have to find out GMR and they're asking the capacitance. So instead of R dash, there will be R. And what is R dash? R dash is nothing but a 0.7788 R. 0.7788 R. Okay, understood this point? Now one more. So this is about the single phase. Now if we talk about the three phase. Now if you talk about the three-phase circuit. So in a three-phase circuit, basically we have a 3 conductors. Obviously बात है. In a three-phase circuit, you have a 3 conductors. So these are the conductor A, conductor B, conductor C. These are the conductors here. So in a three-phase system, you have a 3 conductors. Now, for example, you need to find out inductance because of the phase A. So we'll find out the GMR of a phase. Simple R dash हो जाएगा. Here the simple it will be R dash. Nothing to worry about, है ना? So if you want to find out the inductance here, so for inductance, GMR is nothing but equal to R dash. Whether you need to find out for A, B or C, it comes out to be R dash. And it will be true. For both symmetrical. It will be true for transposed and untransposed line. It will be true for transposed. It will be true for transposed and untransposed line. Untransposed line. It will be true for transposed and untransposed line. Okay, so whatever if a transposition is given or not given, it will not impact the GMR in case of a three-phase line. In case of a three-phase line, understand this point. If you have a double circuit line, if you have a double circuit line, what is the meaning of double circuit line? For example, this is the A conductor, this is A dash. It means from here that current is entering and from here the current is leaving. Phase A current is leaving. This is the meaning of double circuit line. This is the double circuit line. Okay, similarly there will be a double circuit line in each phase. There will be a double circuit line in each phase, B dash, C dash, B dash, C dash. There will be a double circuit line in each phase, B dash, C dash. Okay, now understand here. I want to find inductance here. I want to find inductance here. Find inductance. Okay, so we are talking about GMR. For inductance we also need GMD. But if you want to find out inductance, so first of all find out GMR of conductor A. Find out GMR of a conductor A. What will be the GMR of a conductor A? A distance खुद से A dash, A dash, A dash, A dash, raised to power 1/4. This is the GMR of a conductor A. You can assume it that it is a double circuit line representing a single conductor. So this is a single conductor formula, but understood one point, there will be a two separate conductors here, because we are talking about double circuit line in which one line the current is leaving, from a second line current is coming. Okay, so there are two separate conductors. So GMR of A. Similarly, GMR of B, it will be DBB, DB dash, DB dash, DB dash B, DB dash B dash, raised to power 1/4. Similarly, you can find out the GMR of C. Similarly, you can find out the GMR of C also. Finally, the total GMR. Will be equal to GMR of A, GMR of B, GMR of C. This will be the final GMR, 1/3. This will be the final GMR. This will be the final GMR. Okay? That you need to do in case of a double circuit line. If you don't have a double circuit line, then it is simple. You have a single conductor, find out the GMR there, which is R dash. Simple. But if you have a double circuit line, you have to do this. So there is a rare chance question will come from a double circuit line. Just I gave you for the reference. Most of the time, question will come from either from two separate inductor or from the bundle conductor. So the high chances is for this type of conductor, solid conductor, and the bundle conductor. Understood? So in this way, you can find out the GMR. Any doubt here? Any doubt here? Ask me. Okay. Now let's talk about GMD. Wait a sec. Okay. We'll talk about GMD here. Let's talk about GMD. So GMD means you have to see now two inductors, distance between two conductors. GMD means distance between two conductors. Now GMR you were observing inside a single conductor. Now you have to observe the distance between two conductors. So if you have a case, if you have a case of single phase two wire line, what will be the GMD here? The distance between two conductors. So it will be D. The GMD here is nothing but equal to D. For example, I am talking about GMD because of A. So it's a distance between AB. between two subconductors. Similarly, if you talk about GMD of B, because of conductor B, it will be a distance of that conductor with other conductor. So GMD is the distance between two conductors. So distance of this conductor with respect to this, distance of that conductor with respect to this. So when you find out, for example, I want to find out LA. LA will be 2 into 10 raised to power minus 7 ln GMD of A divided by GMR of A. If you see this circuit, what is the GMR of A? If you see this circuit, GMR of A is nothing but R1. GMR of A is nothing but R1. Similarly, for inductance of conductor B, 2 into 10 raised to power minus 7 ln GMD of B divided by GMR of B. GMD of B, we have find out. What is the GMR of B here? GMR of B here is R2. So in that case, both inductance will be different. Both inductance will be different. And if in the question they ask you the total inductance, if it is mentioned to ask you the total inductance, that will be LA plus LB. That will be LA plus LB. Okay. So GMD means you need to find out distance between two conductors. Okay. Let me tell you one more. Next, composite case. Need one copy. Let's talk about here. We will talk about here only. Let's talk about the composite conductor case. So I'm talking about two separate conductors. Now I'm talking about two separate conductors. So let's suppose this is the conductor A. This is the conductor B. Okay. Inside this I have n subconductors. Inside this I have n subconductors. Inside this I have m subconductors. 1 dash, 2 dash, 3 dash. Okay. Now when I'm calculating the GMD, when I'm 0.5. When I'm calculating the GMD, I will not see inside the conductor A. For example, here I want to find out GMD of the conductor A. So I will not see inside of it. I will see the distance between their subconductors with that subconductors. Distance between this subconductors to that subconductors. Okay. So let's suppose GMD of A is equal to GMD of first subconductor, GMD of second, GMD of n. Raised to power 1 by n. Raised to power 1 by n. Okay. Now start. Whether internal होता है तभी तो 2 लिया है मैं यहाँ पे. Because of internal you have a 2 here. Because of internal you have a 2 here and r dash here. And r dash here because of internal. So GMD1 क्या होगा? Distance of 1 with 1 dash. अब अंदर ही देखना, don't see inside of it. 1 का distance 1 dash से 1 dash, 1 2 dash, so on. 1 m dash. So how many we have? 1 by m, because there we have a m subconductors. GMD2. So distance of second subconductor with the first one. 1 dash, 2 dash, 2 m dash, raised to power 1 by m. Similarly, GMD of n, it is dn1 dash, dn2 dash, dn m dash, raised to power 1 by m. So you can put all of these GMD in above and find out the answer. Understood this point? How to find out GMD? Understood this point? How to find out GMD? There will be no bundle conductor case in case of GMD. Okay, bundle conductor is a property of a single conductor. There is not like you have to find out GMD in that case also. You can use the composite concept only and solve the question easily. So in this way you find out GMD. But again, this is the first single phase question. This is the single phase question. So in this phase you can find out the GMD. Any doubt here? Any doubt here? Tell me. If you have any doubt, you can ask. If you have any doubt, you can ask. Okay. Now let's talk about three phase. Let's talk about three phase. So in a three phase, if you have a transpose line, then GMD is equal to distance between conductor A with B, distance of conductor B with C, distance of conductor C with A, distance of conductor C with A, distance of conductor C with A, raised to power 1 by 3. In case of transpose line, the GMD will be mn होगा. After when you multiply it, Vinay, you are correct. when you put all this value here, because it is 1 by m and it is 1 by n, so it will be 1 by mn. So in case of a transpose line, GMD will be equal to DAB, DBC, DCA 1 by 3. What is ABC? They are the conductors. They are the conductors in a three-phase line. Now you can see you have a symmetrical spacing. This is the symmetrical spacing. So if this is a symmetrical spacing, then what will be the GMD here? The distance are D, D and D. So GMD will be D multiplied by D multiplied by D raised to power 1 by 3. It comes out to be D. So in symmetrical, GMD will be D. If you talk about asymmetrical connection, for example, this is a asymmetrical connection. So just use this formula. So this is the universal formula. For a three-phase line. Understood this point? It's a universal formula for a three-phase line and for the transposed line. If the line is not transposed, then the particular question become very much difficult and that will not come in your exam. So if in the question it is not mentioned that the transposition is happened, by default you have to assume that there is a transposition. There will be a transposition. Okay. So this will be DAB, DBC, DCA raised to power 1 by 3. Now let's talk about double circuit line. Let's talk about the double circuit line. For example, in a three-phase double circuit line, I already told you how to find out GMR in this case. Let's talk about GMD. So in double circuit line, I have A, I have A dash, I have B, I have B dash, I have C, I have C dash. Now GMD, I told you the formula DAB, DBC, DCA raised to power 1 by 3. But the point is how to find out DAB, DBC and DCA. To understand this point, DAB is equal to distance of A, distance of conductor A. If you do one thing. This is conductor A, this is conductor B, this is conductor C. Okay, so it comes out to be DAB, DBC, DCA, like that. So DAB is equal to distance of A with B, distance of A with B dash, distance of A dash with B, distance of A dash with B dash raised to power 1 by 4. Understand this? Yes or no? This is a universal formula. Okay, this is a universal formula of GMD. Now what is DBC? Distance of B with C, distance of B with C dash, distance of B dash with C, distance of B dash with C dash raised to power 1 by 4. Now what is DCA? Distance of C with A, distance of C with A dash, distance of C dash with A, distance of C dash A dash raised to power 1 by 4. Right? So in this way you find out GMD in case of double circuit line, but the chances are very less the question will come from double circuit line. Okay? Any doubt till here? How to find out GMD and GMR? So that we have transmission we have done. Try to solve this question. Like this you can do it by yourself. Try to solve this question. Find the total inductance of a single phase line. Try this one. Find the total inductance of a single phase line as shown in a figure. Try to solve this question. Try to solve this one. हाँ बेटा क्लास की क्वेश्चन होगा ना वो तो है because pattern of questions are same ना 15 में होगा. What about 15 m होगा? mm 15 m. अच्छा मीटर होगा. करेक्ट करेक्ट. नहीं, what is given? R is given 2.5 mm and 15 is meter. 15 is meter. Correct. 15 meter is given and it is 10.81 meter. Correct. So find the total inductance of a single phase line. What is the meaning of this? Total inductance. You need to, total inductance is equal to inductance of A plus inductance of B. This is the meaning of total inductance. Inductance A plus inductance B. Okay? So when you find out the total inductance, one thing you need to understand, GMR of A is not equal to GMR of B. Okay? But GMD of A is always equal to GMD of B if you have only two conductors. है ना? If you have given two conductors, it is a two conductor. This is a conductor A, conductor B. Inside conductor you have a subconductors, right? So if you want to find out distance between conductor A and B, it will be same as distance between B and A. So you only need to find out the GMD of A or GMD of B, anything. So let's first find out GMR of A. Let's first find out GMR of A. So if you see the GMR, if you see the A, if you see the conductor A, it is not a symmetrical image. It is not a symmetrical image, right? So it means I need to find out GMR of subconductor A. It will be equal to GMR of A1, A2 and A3. GMR of A1, GMR of A2, GMR of A3 raised to power 1 by 3. Raised to power 1 by 3. This will be the formula of GMR of conductor A. This will be the formula of GMR of conductor A. Now GMR of A1. GMR of A1. The distance by itself. Distance by itself. The radius given is 2.5. 2.5 and this is 5. Okay. So distance by itself. So 0.7788 multiplied by 2.5 into 10 raised to power. Do one thing. We can calculate separately now. Why to calculate everything here? We can calculate separately. GMR of A1 0.7788 multiplied by 2.5 multiplied by 2.5 into 10 raised to power minus 3 multiplied by A1 distance with A2, A1 distance with A3. So 6 multiplied by 6. 6 multiplied by 6 raised to power 1 by 3. Yes or no? This will be the GMR of A1. Tell me guys. This will be the GMR of A1. Yes or no? Now GMR of A2. We will solve it. GMR of A2. So the distance of A2 with A1, distance of A2 with A3 and distance of A2 by itself. So distance of A2 by A1, 6. Distance of A2 by itself, 0.7788 into 2.5 into 10 raised to power minus 3 multiply distance with a conductor 3. So sorry, subconductor 3. 1 by 3. है ना? And you can see both are the same. You can see both are same. GMR of A3. GMR of A3 is equal to distance of A3 with A1. Achha, I have done one mistake here. 6 and 12. There should be 12 there. There should be 12 ना? Okay, बोल भी दे रहा है. सोगे क्या? Have you slept? बच्चों सोगे क्या? 6 into 12. So A3 with A1 is 12. A3 with A2 is 6. And then it will be 0.7788 into 2.5 into 10 raised to power minus 3 raised to power 1 by 3. Right. Into 2.5 into 10 raised to power minus 3 raised to power 1 by 3. ठीक है. GMR1 A1 में 12 आएगा. हाँ, correct. I have already corrected also. So let's solve it. So 0.7788 into 2.5 into 6 into 12 divided by 1000 under under root 3. So it comes out to be 0.52 meter. This is also 0.52 meter. It is also 0.52 meter. And it will be 6 multiplied 6 multiplied 0.7788 multiplied by 2.5 divided by 1000 and raised to 1 by 3. It comes out to be 0.41 meter. It comes out to be 0.41 meter. Now, can I find out GMR of A? Can I find out the GMR of A? GMR of A is equal to how much? GMR of A is how much? 0.52, 0.41, 0.52. 0.52, 0.41, 0.52 raised to power 1 by 3. So it will be 0.41 into 0.52 into 0.52 and raised to power 1 by 3. So GMR of A comes out to be 0.48 meter. 0.48 meter. Okay. Now, how will you find out the GMR of B? How will you find out GMR of B? Now, it is a symmetrical image. It is a symmetrical. Of two conductors, it will be a symmetrical. So, GMR of B is equal to GMR of B1 only. It is a symmetrical now because we have given two subconductors only. So, it is a symmetrical image. So, only find out GMR due to B1. So, it will be how much? Distance of B1 by itself. 0.7788 into 5 into 10 raised to power minus 3 multiply distance of B1 with B2. कितना है? 6 meter. 6 meter raised to power 1 by 2. 1 by 2. So this will be the GMR of conductor B. This will be the GMR of conductor B. 0.15. 0.15 meter. Now we need to find out the GMDs. So the GMD of both are same. So how will you find out the GMD? See very carefully. Distance of A1 with B1. Distance of A1 with B2. Distance of A2 with B1. Distance of A2 with B2. Distance of A3 with B1. Distance of A3 with B2. Okay, now let me write down again. Distance of A1 with B1. Distance of A1 with B2. Distance of A2 with B1. Distance of A थोड़ा सा ठीक कर लो बस हो जाएगा. So distance of A1 with B1, A1 with B2, A1 with then A2 with B1, A2 with B2, distance of A3 with B1, distance of A3 with B2, raised to power 1 by 6 because we have a 6 numbers here. है ना? Right? Now distance of A1 with B1 कितना है? 9. A1 with B2 कितना है? 10.81. So 9 multiply by 10.81 multiply A2 with B1. A2 with B1 कितना होगा? 10.81. A2 with B2 कितना होगा? 9 होगा. 10.81 multiply by 9 multiply A3 with B1. How much distance? 15 meter. A3 with B2 10.81. So 15 into 10.81 raised to power 1 by 6. Now you can solve it. Tell me कितना आंसर है? Tell me guys. $10.74 meter. 10.74 meter. So finally we have GMR, we have a GMD. We can find out inductance. So inductance of A 2 into 10 raised to power minus 7 ln GMD of A, which is 10.74 or 0.48. 10.74, 0.48 Henry per meter. That you can solve by yourself. Inductance of B 2 into 10 raised to power minus 7 ln 10.74 divided by 0.15 0.15 Henry per meter. And finally, they are asking the total inductance. So LA plus LB. They are asking a total inductance, which will give you LA and LB. Right? Solve it. Okay. In examination, don't worry about this. In examination, they if this question will come na, they will ask you inductance due to one conductor only, not the total. They can ask you inductance because of A, because of B. So in examination they are not going to ask the total inductance. That's why we are the time has been consumed here. But ये है कि you have understood how to find out GMR and how to find out GMT. That is a special point, because in examination they can also ask you just find out the GMR due to A, not inductance. They just give you the this type of network and ask you find out GMR due to A. Understand here? Understand? Any point, any doubt in this question? Also, this is the advantages of a bundle conductor. This is the advantages of a bundle conductor. That effective radius of a conductor increase, inductance per phase reduce. You have to remember this. It will come sometime. This question will come for the 1 mark, or because of MSQ type of question, they can give you one option based on the theory part. So because of MSQ type question, these points are become very important for the examination. Earlier, there was a less chance the question will come from theory, but now the chances have been increased because of the MSQ type of question. Again, inductive reactance per phase reduces because the effective radius increased, and power transfer capability increase, corona will reduce. So these all points you should understand here. These all points you should understand here, right? If you have any doubt in any point, you can ask. If you have any doubt in any point, you can ask. Now, insulator is also important topic. Insulator is also important topic for examination. So we are just going to see insulator. This is going to be a last topic. I will soon plan one class based in which one class again for the power system, where I will discuss the question based on the stability. तो stability के लिए एक अलग से class हम रख लेंगे, because that require at least 2 to 3 hours for the stability, for that revision. ठीक है? So suspension in this let's talk about not theory part, let's talk about the numerical part. So we are using the in insulator we basically use you go for a distribution. Distribution part is easy, Arun. Distribution part is easy. For example, this is a distribution part. What's the problem in distribution? You just need to know how to apply KCL, KVL, and you can solve the question of distribution easily. For example, you have a DC distributor. See, one more thing, in a distribution, 99% chances that question will come from a DC distributor. For a AC distribution, the calculation become lengthy and you don't have a manual calculator there. Yeah? As a string you have done in special subjects. Power system protection. But the whole concept is of theory. With a power system protection, the complete concept is of theory, na? That you can do it by yourself. There is not any special thing that we can explain there, na? Because you have a circuit breaker, which is complete theory, but the question from a circuit breaker chances are less. The question come from relays, that is again a theoretical part, you know. So now in a special subject series, I have taken the class over that, if I'm not wrong, you know. I took that class, no? String wali. Okay. So distribution, you can see the distribution. Distribution very much easier. First of all, they will give you the DC distribution, है ना? Because for AC distribution, the calculation part become very lengthy and you don't have a manual calculator there. Second point, how to do the distribution. First of all, you need to understand, you just need to apply KCL and KVL, and from that you can solve the question of distribution easily. For example, see here very carefully. This is the radial distributor. Radial distributor means all the load are connected one by one. All the loads are connected one by one. That is the meaning of radial distributor. We have 3 types of distribution. One is a radial distributor. One is a ring distribution. Here you can see this is the ring distribution, and one is the interconnected distribution, interconnected system. So if you see the radial distribution here, there are number of load which are connected to a distributor. Now in the distribution system, we consider load as a current. Ki how much current they can actually absorb, how much current they are actually demanding. That is actually a load here. So let's suppose the current I is coming in this direction. It is I1, it is I2, I3, I4, I5. Now, because of this, you can distribute the current in each and every distributor. So I is coming, I1 is leaving, I minus I1 is going, then I2 is leaving. In this way, you can distribute the current easily. Now, 2 points you need to understand here. First of all, this resistance, the resistance will be given in ohm per kilometer. The resistance will be given for a ohm per kilometer. The resistance will be given in ohm per kilometer, in which you have given the distance of each subsection can be different, can be same, and you can find out resistance of that subsection. Okay, one thing. Second thing, if in the question they have mentioned that it is a loop resistance, if in the question they have mentioned it is a loop resistance, then you can use the R directly. But if they mentioned resistance of single conductor, if they mentioned resistance of single conductor, resistance of single conductor is equal to R. If they mention like this, then the loop resistance will be 2 times of R. Then loop resistance will be 2 times of R. Loop resistance will be 2 times of R. This you need to understand here. This you need to understand here. This is the second point. If nothing is mentioned about resistance, neither the loop, neither the single conductor, so this you will take by default. This you will take by default. This you will take by default. Okay, understand the point till now? Understand the point till now? Now see very carefully. Let's suppose the length of this particular is L1, the length here is L2, and the length here is L3. Okay, and this is the point A, B, C, D, E. Now tell me what will be the voltage drop between AB. Okay, Vinay. What is the voltage drop between AB? The current I is coming multiply by the resistance R1, L1, because resistance are given in per kilometer. Now, if you talk about VBC, what is the drop here? What is the drop here? I minus I1 multiply by R2, L2. Same if I talk about VCD. So the drop is I minus I1 minus I2 multiply by R3, L3. So in this way, you can find out the drop in each and every section. You can find out a drop in each and every section. Now, if you know the voltage here is A, if you know the voltage here is something else, so you can write down directly that the voltage difference between AF is equal to AB plus BC plus CA, sorry, AB, BC, CD plus DE plus EF, and this will give you the equation. This will give you the equation, and you have to solve this equation accordingly. You have solved this equation accordingly. For example, let's do one question over this. Now, in this case, when they are feeding from both the ends, when they are feeding from both ends, for example, it is X, it is Y. When they are feeding from both the ends, can you say Vx minus Vy is equal to V1 minus V2, or you can say Vx minus Vy is Vxa plus Vab plus Vbc plus Vcd plus Vd by is equal to V1 minus V2. So when there is a feeding from both the ends, you can represent like this. You can represent like this, है ना? But let me tell you one point. If the question will come that the feeding is happening from both the ends, so remember, you only going to take the current from one end. For example, assume that I1 is flowing here, then I3 is leaving, it is I1 minus I3. Let's suppose I4 is leaving and it will be I1. Let me explain you. Let me explain one thing. Let me explain you. Wait a sec. Let me find the space. Let me find the space. Let's suppose here. Suppose I have a different loads connected. Let's suppose I have a different load connected like this, and the feeding is happening at both ends. Feeding is happening at both ends. This is V1. This is V2. This is the load I1, I2, I3. This is the load I1, I2, I3. Okay. Now understand this concept, because from here the question will come. So let's suppose the current I is flowing here. This I am assuming. This I am assuming. Current I is flowing here. So how much current will go there? I minus I1. How much current will go there? I minus I1 minus I2. And how much current will go there? I1 minus I1 minus I2 minus I3. I'm not considering the current given by the V2. I'm not considering the current given by the V2. I just consider the current given by the V1. Now from here, let's suppose it is A, B, C, D, E. So from here, I can write down one equation that V1 minus V2 is equal to VAB, VBC, VCD, VDE. है After this equation, we find the value of I. After this equation, we find the value of I. After finding out the value of I, find current in each section. Find current in each section. Find current in each section. For example, you are finding current in IAB, IBC, ICD, IDE, and the particular node at which you are getting a negative current. The section in which you are getting a negative current. For example, let's suppose IAB is positive. Let's suppose IAB is positive. IBC is also positive, but ICD comes out to be negative. ICD comes out to be negative. So the particular branch where you are getting a negative current first, that particular node will have a minimum voltage. Then that particular node will have a minimum voltage. That particular node will have a minimum voltage. For example, here it is a positive current. Here also it is a positive current, but here it comes out to be negative. So it means this particular node is the minimum voltage node for the complete system. So sometime question will ask you to find out which node is minimum. They can ask you find out the voltage at minimum node. For example, if I want to find out voltage at minimum node VC, how we can find out? VA minus VAB plus VBC. है ना? Not VA, V1. V1 minus VAB plus VBC. Because this is V1, there will be a 2 drops here, then you will reach to VC. Understood this point? Yes or no? Everybody, tell me. Understood this point? Yes or no? How to find out a minimum voltage? How to find out the node of minimum voltage and the magnitude of minimum voltage? Node of minimum voltage and the magnitude of a minimum voltage. कोई डाउट इसके अंदर? कोई डाउट? Okay, so in this question, let me draw the question again. 1, 2, 3, 60, 40. 20, 60, 40. This is 20 ampere. This is 60 ampere. This is 40 ampere. Okay? From here, right? So it is V1, it is V2. Now V1, V2, this is A, B, C, D, E. Okay? Question is given V1 equal to V2 is equal to 230 volt. V1 equal to V2 is 230 volt. Resistance is given 0.15 ohm per kilometer. Then find minimum voltage node. Try this one. Let me tell you 50, 100, 50, 100. So it will be 50 meter, 100 meter, and again 50, 100. It will be 50 meter, 100 meter. Okay, let's do one thing. Instead of kilometer, it is 0.15 ohm per meter. Okay, try to solve this one. We need to find out the minimum voltage node. Try करो एक बार. Everybody, try this. Find out minimum voltage node. A, B, C, D, E. A, B, C, D, E. Try करो. Everybody should try it. Everybody should try it. V1 equal to V2 or find minimum voltage node. Find the minimum voltage node. So how we can solve this question? How we can solve this question? So let's suppose here the I is going. It is also I. It is I minus 20. Sorry. It is I minus 80. है ना? 20 गया, 60 गया, 80 गया, I minus 120. I minus 120. Now we have VAB plus VBC plus VCD plus VDE equal to V1 minus V2 equal to V1 minus V2 है ना? तो VAB कितना हो जाएगा? I multiply by distance 50 multiply by 0.15. 0.15. VBC will be how much? I minus 20. I minus 20 multiply by 100 multiply by 0.15 multiply 100. I minus 80 मतलब VCD कितना जाएगा? I minus 80 multiply by 50 multiply by 0.15 and it comes out to be I minus 120 multiply by 100 multiply by 0.15 and V1 and V2 are equal. V1 and V2 are equal, so it will give you 0. V1 and V2 are equal. Solve करो इसको कितना होगा? Try to solve this. Try to solve this. Find out the value of I. Let me use the calculator also. So we have 50 into 0.15 plus 15 plus 7.5 plus 15. So it comes out to be 45 I1. 45 I. है ना? 45 I equal to 20 multiply by 100 multiply by 0.15. 300 हो गया. Solve this. Plus 80 multiplied by 50 multiplied by 0.15 plus we have 120 multiplied by 100 multiplied by 0.15. 2700. It comes out to be 2700. So I will be equal to 60. I comes out to be 60 ampere. I comes out to be 60 ampere. है ना? I comes out to be a 60 ampere. Good. Now if it is 60 ampere, so let's find out current in every branch. Let's find out current in every branch. So it is 60 minus 20, it is 40 ampere. Now 40 minus 60, it comes out to be minus 20 ampere. So negative current happens here. It means node C. It is the minimum voltage node. So node C, it is the minimum voltage node. You can also find out voltage at C, which is equal to drop across AB plus drop across BC subtracted from V1. Understood? Yes or no? Yeah. So these are the important topics we have covered today. Okay, I will share the PDF on my Telegram channel. You can join my Telegram channel. Let me write down the name again if you forgot. Electrical Electronics by Ishan Mudgal. So yesterday's class PDF of network theory and today's PDF also, I will share it on the Telegram channel. Also, don't forget that you have to give the test also. You have to give a test also. Not directly right now, but try to give the test in 1 day or 2 day form. VC कैसे find करें? VC is equal to V1 minus VAB plus VBC. You know the current, you know the resistance, the drop pata hai, resistance pata hai. You can find out VC. Understand now? Yes or no? VC you can find out this way. So either you can scan this QR code or the description link with the description will link with the you can get the quiz from there also. But bachcho, practice a lot because the core subjects require a lot of practice. Whether it's a power system, power electronics, machines, it requires a lot of practice. Okay. How it will be 820 बच्चे विनय 820 कैसे आ सकता है 820 कैसे आ सकता है you are doing a calculation wrong. Tell me one thing. V1 is 230 minus VAB. It was 60 multiplied by 0.15 multiplied by 50 plus VBC was 60 minus 20 40 if I'm not wrong 40 multiplied by 0.15 multiplied by 100. This will be the equation na. This will be the equation na. So let me solve this. कितना आएगा? इतने आ रहे कुछ और अलग 820 आ रहे. Let me check. Wait a second. Maybe the value, there was a problem with the values. There's a problem with the values. So let me check. This was the question, no? This was the question. So 60 into 50 into my 0.15 and then 40 into my 0.15. कमी आना चाहिए. I guess I have taken a different value from there now because it is written 0.15 ohm for 300 meter. 0.15 ohm for 300. We have taken the larger value of resistor. And it is actually given you. Minus 550. If you calculate here, it will given you minus 550, not 820. It will given you minus 550 volts. That's because I have taken a large value of resistance. That's why. Because I have taken the large value of resistance. That's why. Okay. I have taken a large value of resistance because in this question, resistance given 0.15 ohm for 300 meters. Okay, that's because of the resistance value. Yeah, but the concept is that you have to subtract both voltage drop, this voltage drop from the V1. And a simple KVL method, nothing more than that. Okay, so we are going to end the session here, bachcho. So if I'm not wrong, tomorrow there is another session for you. I guess Rakesh sir will take the session. And ABCD parameter, you can remember the ABCD parameter for a short transmission line, medium transmission line, for a long transmission line. The question will come in the sense that they will ask you the voltage regulation. So try to solve the question based on voltage regulation. You know, in case of short transmission line. In case of short transmission line, when you go for a medium transmission line, the question based on Faraday effect can come. Also, the question based on a compensation, like shunt compensation, like your synchronous motor compensation. You know, so these type of topics. So there is a time left. Try to give maximum time this week in your power system, so that at the end of this week you will at least revise 80-85% of your syllabus. Right? But dispatch, why you are worried about dispatch, bacha? Why you are worried about dispatch? Have you completed all the topics before? Because dispatch will come maximum of 2 marks, and that is also the 50% chances. But the topics which are which have the more chances to come, focus on that topic now. Because if you haven't done the dispatch already, then leave it. There's only 2 mark question. Why you are worried about that? Worried about the remaining 10 marks of power system now. Okay. Anybody else? So yeah, so we'll end our session here. Yeah. So bye guys. Take care. Tomorrow you will have another session with, I guess, the Rakesh sir or the Sanjay sir. तो अच्छे से पढ़ाई करो. All the best.